Hello, everyone. Welcome to another star party for the Fort Worth Astronomical Society. I'm Chris Modnitsky. I'll be your host for tonight. It is a very, very cold evening. It's going to get even colder. So right now, we are back in Burleson in my backyard. We're not shooting from Grandview. Today, we're going to be doing some interesting stuff, though. We're going to be trying for some uh, deep sky photography in light polluted skies. So what we're going to be hoping for is some nebula, some clusters. We're going to try a couple galaxies, see how well they come out. And we're going to be doing some spectroscopy. So spectroscopy is taking the light from a star or a planet, really any light source, and then splitting it up. Once we split it into a spectrum, from red to blue, we're going to be able to tell what elements are in the atmosphere. So we're going to be playing with some stars today. Excuse me. Been fighting a bit of a throat infection this past week, so if I'm a little bit hoarse, sorry about that. I probably should have gotten something to drink, but that's okay. Let's go ahead and get right into it. So right now I have, you can see behind me, I've got the mount ready to go. I've got two telescopes. I actually have a number of cameras on here right now. Trying something a little bit different. I've got a mono camera, a color camera. I have the guide scope and the guide camera, and I also have one of my old guide scopes, and I've attached a rather cheap lens onto it from a old, I think it's like a 16 millimeter or a TV camera. And we're going to be showing a wide field of the sky so that you can see what we're talking about when we're looking in the sky. With the telescope, especially with a high power telescope, you see such a very, very small portion of the night sky. All you really see is, uh, like, even if it's a wide field scope, you only see a couple of degrees. And the moon itself is half a degree across. And I'm going to see, I think we can capture the moon. We've got a fairly decent crescent right now. We're probably going to do that first because the moon is about to disappear past my roof line. So we're going to see what we can find. Right now, I've got everything set up on the scope. I think it's aligned. We're going to test that right now, but it's definitely out of focus. We'll have to fix the focus. That's not too much of a problem. So if you have any questions, go ahead and put them in the chat, and I'll be paying attention to that. If you have any issues, if the audio is not coming in clearly, if there's some other thing going on, just go ahead and let me know. I check back with the chat, and we'll go from there. So stay tuned for a bit. We're going to be here for a while. It is a cold night. That's okay. I was actually out here last night till about 1 o'clock. I was going to do the star party Saturday nights when I typically do them, but it was cloudy until about 11:30. And then the skies cleared up quite nicely after midnight, and I was able to do some imaging, some testing, and it looked really, really nice last night. It was quite still. We don't have a wind. It's just going to be cold. So I'm bundled up in case you can't tell. I've got a hat, I've got a hoodie, I've got a nice warm sweater over this. I have a coat on the back of my chair for when I will need that. The only thing I'm forgetting is hand warmers. It's okay. I'll survive somehow. And a big pot of tea. I could use a big pot of tea, but that's later on. Time is a wasting, time is a burning, and we need to start looking at the moon. And I'm looking for remote control. So many things to look at. So first things first, I think I have the telescope aligned. We're going to switch over to the other view. Let's see, is there any questions, comments yet? No, not yet. Okay, cool. Laser guy. Yeah, it's cold nights are actually the best nights for this though, because the cameras get cooled down. You have a lot less noise on the cameras. The air is usually really still. We don't have to worry too much about like high altitude winds. We just get better images on a night like this. So these are fun nights to do imaging, but cold nights are ideally it's something that you want to do in an observatory where you have your telescopes in an open area and then you're in a warm room. If you're in the warm room, you can stay warm. So that's a plan, maybe later on this year. Let's go ahead and get into it. I've made some modifications, and I hope this is going to work. Let's see how well this works. I'm going to go back, and what I'm going to do is I'm actually controlling this from a handset because I'm still having software issues. So we're going to go deep sky. We're going to go look at the moon. Let's see. Let's see how well this works. So you can see it's moving. I have to kind of get out of the way. I came in a little bit too close, brought my equipment too close to the telescope. That's quite all right. So I'm going to go ahead and switch to, let's see, which one did I have? All right, there we go. So we're running SharpCap right now for the software, and waiting for it to slew over. Hopefully there'll be something in the field of view, and then I will have to go in and play with the focus. So in the meantime, I will switch over to this. Let's see what we can see with this camera. I'm constantly going to be getting little errors that pop up. That is okay. So we're going to go zoom. There we go. Something's coming up. So we're going to go 100%. You can see a upside down view of me. That's my head. All right, that's not a good shot. Let's do this. I'm going to kill the lights. And what do we see? This is definitely not the moon. That's my house. The moon, I believe, is right over here. So we got to start playing with this a little bit more. Let's do, I don't think this is aligned. We may have to actually do the alignment later on this evening. In the meantime, no. Yeah, this is pointed way down. There's the moon. Yep. Yeah, it's always figuring out what direction we're looking. It goes. Nope, wrong direction. It's always in the wrong direction, isn't it? So this is not a very great view, but I'm going to switch this over to RGB 24, and I'm going to take a much longer exposure. What I'm trying to do with the longer exposure is, there we can kind of see me there. The longer exposure is going to let me pick out stuff around it. So we're going to go into, let's see how long we can do, 20 milliseconds, 400 milliseconds. So there we go. So can't really see much around there. What I was shooting for last night was actually much longer. I was doing 4 and 8 second exposure. So I'm going to do a 8-second exposure. And I thought I'd change this. So I believe somebody is knocking. Okay, close. I've got to get rid of that error. Okay, so I'm doing ooh, there we go. So what are we looking at? We're looking at the moon, and we're looking at all the stars around it, and everything is upside down. It's not supposed to be upside down. I will have to fix the camera. I thought I had it right, but I guess not. So not a big deal. But this is the area of the sky that we're going to be looking at. And what I have, this is one of my planetary cameras, and I put the lens on top of it just so I could. I think that's actually my son knocking at the window. I put a television camera lens on it. The camera lens lets me get a really wide view, and this is something that we'll be doing. So I will have to flip that around, but let's see if I can get the other cameras to work. Next, we're going to jump to the guide cam. Close. So the guide cam is basically like a finder for us. I want to find out what am I looking at. And change the zoom back down to 40. Okay, so we're a ways off. I'm going to have to go back to the camera. And let's see if I can do this. All right, we're going to do 10%. I'm going to go back to the telescopes, actually. And I'm going to get it onto the moon so we can actually do something. All right. I guess do it this way. So I'm using my finder. I'm actually close. There we go. Hard to tell. There we go. Okay. That is way too long of an exposure, so let's bring this way down. There we are. So we're going to change this from mono 16 or mono 8 to mono 16. A little bit more bit depth to it. I swear this error is going to drive me batty. Which direction? So I'm up. Let's go over. Nope, wrong direction. So what are we looking at? Looking at the moon. Not a great image of the moon, but that's okay. This is the finder view, so we're going to switch to a better one in just a bit, but I want to see what happens. I want to play with this just a bit. Yeah, that's way overexposed, but we're at 16. Yeah, okay. I'm going to kill the gain. Instead, I'm going to drop this way down. But this is not terribly in focus. That is not a problem because this is a finder scope. So it's not a very sharp telescope to begin with. But that's just, oof. It should be better. It should be a little bit better. That's how we're looking on there. Let's switch to a different camera. And I know this one is out of focus. Because the temperature right now is not nearly as cold as it was before. Closed, yeah. I probably should have done it on something else. So here's what we're going to do. We're going to switch over from RAW 8. We're going to go to RGB 24. How well you can see that. So we're just picking different bit depth. That's not too bad. And I'm going to zoom in. 100%. Yeah, we're going to zoom in right to here because I've got to go back and fiddle with the focus. Let's see. We're getting there. Oh, we're getting there. Too much. That's not bad. That's not bad. Okay. Let's see how well that does. So, looking actually, I've got to look at two places. I have to look at a good monitor, and then I have to look at my laptop monitor. My laptop monitor, the color is kind of off. So I'm going to bring this way down. I'm going to kill the gain. Oh, yeah. The reason why I want to kill the gain is because I want it as raw as possible. Let's bring this up. There we go. Yep. All right, so what are we looking at? Looking at the limb of the moon. And what's nice is that in this view, we can get the entire moon in the field of view. We're looking at the terminator. And it's not quite as sharp as I would like it. So, because we can go in pretty deep. Then again, this telescope is a wide field scope. It's not horrible. Now, there is some motion, and this is mostly with the air currents. So what's going on right now, this is directly above my roof line. And I guarantee you my attic is warmer than the surrounding air. So when it is, you have these thermal currents that come off of it. Just, it is what it is. So we just kind of have to deal with it. We can at least see some detail. That's not too bad. So we can see these overlapping craters. I don't see any rebound mountains yet. But it could be that the focus isn't quite where I want it to be yet. To really get it on there, we have to switch over to something else. There'd be a rebound mountain right there. I actually have to switch it to a different object. I have to switch to a star and put a mask, a Batinov mask on there, and then with the mask be able to do more. But this isn't, well, it's not great. Let's see if we can get a little bit better. That was me. Okay. Better. That's pretty good. That's better than what it was before. Now we're seeing some details. We're seeing some rebound mountains. We've got one right here. This isn't too bad. Rebound mountain right there, rebound mountain right there. So if you remember from last time or previous times when we've had this discussion, if you have a large enough, let's start with small. So if you have a small meteoroid or small asteroid that impacts, it makes a simple crater. It blasts out what's there and leaves a hole. You have a little bit of melting, you have shock, but it's not a whole lot, and it's just at the surface. If you have a bigger asteroid, it will hit and it will melt the rock and vaporize part of it. When it melts, it splashes out, and then when gravity pulls that back in, it will make this little peak in the middle, just like a droplet of water. And the difference is the rock will freeze into a mountain right there in the center. The water will make a little hill or a little rebound mountain as well, and then it'll go back away and it'll keep doing this for a bit. In this case, we just have a rock mountain that forms in the middle. If it's big enough, you don't have a rebound mountain, it punches right through the crust and hits the mantle. Then you have a feature like this, where the mantle material wells up and fills out the bottom of that crater. Let's see. I'm going to jump over, see how many questions. Minimize this. There we go. So I got George there. All right. Yep, stream began a while ago. Okay, what else can we do on here? So this is a little color camera, and it is pretty much doing what it's supposed to be doing. So I'm going to turn on the cooling and let it cool down. So right now, what are we seeing? Ah, here we go. So we can see some mare. Mare are the seas of the moon. From the Latin for sea, mare. They're not true seas, but this is the dark basaltic material. This is the stuff that came up when a large enough asteroid hit it. So here, something hit that asteroid hard enough. Sorry, an asteroid hit the moon hard enough to punch all the way through to the mantle, crack right through the crust, and that material welled up, filled the bottom of the crater, and eventually this is all that's left. And we can tell this is younger than some of the other areas because there aren't nearly as many craters. So the moon went through a couple of like major bombardment periods. It's like, well, one major one, the early bombardment period, and then some others. Um, but we can age an area, whether it's younger or older in comparison to the areas around it, based on the number of craters. We just kind of assume that crater impacts are fairly evenly distributed across a face of the moon. So if you have an area like this where you don't have as many craters, we assume it's younger. Now, what's really interesting is the far side of the moon actually has a lot more craters than the near side. And the reason for that is the Earth. The Earth kind of either absorbs or deflects a lot of asteroids and meteoroids. So the near side doesn't get nearly as many impacts as the far side. Either it hits the Earth, or or it just gets flung out. On the back side, though, it does impact directly because it doesn't pass by the Earth. So that's some interesting trivia right there. And if I have it, let's see. Here we go. So if we look at this, this is a starry night. And normally I would use this to control my telescope, but my new mount does not actually work with starry night, which unfortunately. So this is what is it? Eckert Mare Crisium. Yep. Then we can see this mare over here as well. I'm just going to do this. I'm going to center. We can see and then zoom out. So we have another big mare right there. Let's see where that one is. There we go. One, and then over here. That's the other big one. And then we can see another rebound mountain right through here. And the view is not going to get much better because it is almost at my roof line. So it's going to disappear very shortly. So I wanted to kind of grab the moon while we could. Rupes Recta. Rupes Recta. Where is Rupes Recta? We have to go dig it up because I'm not that good at finding it. So this is a question from John. Rupes Recta. Is that it? Rupes Recta. This is nothing was found. Sure that's right spelling? Rupes Recta. There it is, a scarp. Let's see, where is it? Zooming out. This is not where I wanted to be. I wanted to view it. Let's go back home. So we're going to go back home. Instead, we're going to view this. Center. Hello. How about this? Just mark it on the surface. All right, where can we see it? Center of the moon. No, we can't see it. That is a feature for 2 weeks from now. Sorry, John. Does that water droplet effect happen mainly from slow motion and relatively slow motion? Relatively, yes. It's going to be a lot slower than it would be with a droplet of water in a cup. The thing with this, there's a lot of rock to move. There's a lot of rock to melt. If you see it, that initial impact, the initial impact will be fairly quick. It's not like Hollywood where it slowly comes in, comes down, and then smashes and everything blows up. It's going to be quick. Remember, a lot of these impacts, especially for the Earth, it's going to be hitting anywhere from 7,000 kilometers a second to, I think it's like up to 72,000 kilometers. It just depends on, it's a whole lot of factors. Where it's coming in from. Does it impact head on? Does it impact like trailing? Does it catch up to the Earth? Is it oblique? Is it direct? There's a whole lot of factors on how fast it comes in. But if it's going that fast and it smashes that quickly, 7,000 miles, no, 7,000 kilometers per hour. I think that's it. No, maybe even faster. I don't remember off the top of my head. Right. It's fast. So it will impact very quickly. It will melt, it will get pushed out, but then gravity will cause it to slump back in. So that slumping process may take minutes to hours to do, depending on how big it is. Especially on the moon, since the gravity is 1/6 that of on Earth, it's like this. It's like if you take sand and you pile it up on Earth, the higher you go, the more is going to slide down the sides. Gravity is pulling it down and trying to get it to an equilibrium point between friction between the grains and being totally flat. You don't have that much friction if everything is melted, especially if it's a high temperature melt. But gravity is still going to have to pull all that back. And at 1/6 the gravity of Earth, your slumping is going to be 1/6 as fast, basically. If everything else is identical. It's not, but roughly that. So yeah, it's going to be much, much slower. If we could see a large enough impact to do that, it would be really, really interesting. But you would have to have a satellite that's really looking at that all the time, because if you have anything that's orbiting, it's only good to be able to catch passes of it. So if there's initial impact, and you see all that melting, you're not going to be able to like see it from start to finish on a close orbiting satellite, you would need something like on a lunostationary orbit. So that's a orbit around the moon that stays over the same point of the equator of the moon, or like a Lagrange point or something where it's fairly stable. It doesn't really orbit the moon. It stays at a position. Well, okay, let me rephrase that. It does stay. Actually, no, you couldn't have a. Could you have a lunar? No, you couldn't. You could not have a lunar stationary orbit. That is, I don't think you could do that because the same. Because you would have to have an orbit of 28 days, 29 point whatever. And yeah, we can't do that. Huh. That's actually interesting. Could you do one? I don't think you can. Because you would be orbiting so slowly, you would fall right back in. I'm going to have to spin up Kerbal Space Program and test that. If you haven't played with Kerbal Space Program, I highly recommend it. It is it's a nifty little program that lets you build rockets, and you have an entire solar system to explore. You start from basic rockets, you build them up, and you just explore your entire solar system. And it's really neat. It teaches you all about orbital dynamics. You can do things like capture asteroids and bring them in. I have not tried capturing an asteroid and crashing it into a planet yet. It doesn't actually do anything. It just kind of lands. But you can do really, really neat stuff with it. And it teaches you about how to do orbits. Like, it's a really neat program. If you haven't seen it, get it. It should be relatively cheap. So we're going to do this. Turn on planets. I'm going to turn on some stars. Big bright ones. We're going to go turn on some deep sky stuff. Okay, so the moon is about to disappear. Let's go. Let's see what this looks like here. Yeah, we're not tracking it too well, but that's okay. Any other questions? Highly recommended app, a website for star. Okay, John on the spot is asking, this is a valid question. I would like to know what is a highly recommended app or website for star, nebula, etc. location for very amateur astronomy, free or reasonably priced. For the phone, I really like. It's the same company that does Starry Night Pro, and it is Sky Safari. There is, I don't remember if there's a free version, but it is relatively cheap. Google has a free one as well. It's like, I think it's called Sky Map or something similar to it, but it's a Google product. It is very, very, very simple. It does work though, works really well. Let's see what else is there. Those are the two that I know offhand. There are probably others. I know that both Google and Sky Safari, they will use your phone sensors. So you can actually, if you don't know what you're looking at, what you'll do is you'll turn on the application and you'll hold it up to the sky and it will move with you. So if you see a star and you don't know what it is, or a constellation, and you think you know what it is, but you're not really sure, you can use the application and it will tell you what it is, what you are actually looking at. And you have to play with it a bit because if you tilt it too much, you're not looking at the right place. You have to make sure that it's kind of dead on and just kind of follow around. There may be others that use augmented reality. I haven't looked into that. It's actually something I might look at for next time. Test it out, see how that works. But what that would do is that would use your camera on your phone, and it would then pick up the stars, I guess, and then draw constellation lines or something else. The only issue I have is, well, let's do this. This is a good way to compare it. This is my phone, okay? This is a Pixel, what is this? Pixel 2 from Google. So that's the camera. Is it? Yeah, that's the camera lens right there, okay? It's not very big. It's not very big at all. Can you see it? Yeah. So it's tiny. The telescopes, the refractor is 101 millimeters across for the lens. That's that one. The other one, right behind my head and just over, is a Ritchie Chrétien RC that has 8-inch 8 inches of apertures. The one you're looking at right here, this is 4 inches of aperture, 101 millimeter. I'm able to take a very, very quick exposure to see this. With a phone, the aperture is so small that you're not sucking enough photons to really see much. I know that Google has the night view mode, and I've used it before, and it's okay, but you have to hold the camera steady, and it takes a number of pictures and then adds them up together, basically a live stack. And it's okay. It does work. It's not going to be the greatest of pictures though, and it's not going to be nearly as good as something with like a DSLR with a good lens on it. So let's say you have like a 50 millimeter f1.4 or that really nice 50 f1.2. That's going to gather a whole lot more light and put it on a much bigger sensor. Cell phones have tiny little lenses and tiny little sensors, so you're not getting nearly as much photons. That's why I don't think an augmented reality application like that is really going to be the way to go. Something like Google or Starry Night Pro, I think that's going to work better. And Starry Night Pro, I think there's a free version, not Starry Night Pro, Sky Safari. Check out Sky Safari. There may be a free version. Again, I haven't looked. I use the paid version because I actually use it for a bunch of other stuff. I need to connect it back to my telescope as well to see if I can control it from the cell phone, which is always cool. But I'll do that later. So John is giving some more information on what's needed. Yeah. So Sky Safari on iPhone has the base price of $2.99. Okay. So for $3, you can have that, and I think $3 is worth it. I think I paid $20 for mine, but I use it. I use it quite a bit. So for me, it was definitely worth it. All right. So we're still looking at the moon. We're not tracking too well, but I really not really caring right now. We have some highlands, some mountains all through here, and it's not too bad. So we have a lot of overlapping craters here. So we have an older crater first, and then a younger crater that smashed, and then yet another crater. Actually, this big one is the oldest. Then came this one, and then came this one. You can tell because of the way that they overlap on the edges there. So I'm gonna bring this up. Let's see if I can. I'm actually gonna bring this up on a different monitor. This is Nebulosity. This is another capture program, but I've got to get. Let's see if I can get this thing to work. Whew. Well, I don't think it's gonna work well. No, I don't think it's gonna work. All right. I'm gonna switch the camera. Okay. I don't know how well this is gonna work. We're gonna find out. Nope. Okay. This is all ASCOM stuff? Yes, this is ASCOM stuff. Oh, here we go. Let's see how well this works. I don't even think this one's in focus. I'm pretty sure it's not in focus. Probably close. Ah. So that is definitely not in focus. All right, let's knock it down. Oh, wow. All right. I'm going to go down 25%. This is bright and not in focus. So we're going to go modify some stuff first so we can actually use this one. Speed is okay. I got to get rid of gain. Killed gain all the way down. Okay, so we have something. I don't know. It's the moon, but it's way out of focus. How far? That's way over there. All right. I'm going to go back and see if I can get this thing in focus. All right. What is that? That's, oh, I know what that is. Okay. All right. Yeah. It is actually fairly in focus. I just have a filter on there. And that is the spectroscopy filter. So we're going to switch cameras to go back to the previous one that we had. And I want to test this one. Let's see what we're looking at. This is my, this is the other view, close. Yeah, so we got the moon right there in the middle. Okay, and the rest of my house. So we're fine on this. Here's what we're going to do now. Moon is, I can't even see the moon, so it is almost over the edge. You can see here's my roof line right there. And I will, in fact, I'm going to do an 8-second exposure. I'm not really concerned about that. This is actually one of the lights. Let's see. Yeah, way too bright. How about I kill that? See if this makes any difference. I don't think it will. It is getting way too much light now. There we go. Okay. So yeah, it is almost at my roof line. We're not going to worry about it. Instead, we'll jump off to a different target. So I need to do better focus. The way you do it is with a star. So I can see. Oh, yeah, that would do it. Oh, yeah, I know why my alignment's off. I aligned to the wrong thing. Sirius is what I aligned it to. Sirius was below the horizon. Here's what we're gonna do. We're gonna zoom out. Zoom out. Bear with me. Okay. So where are we looking? Southwest, west. We're looking to the south. Sirius is right there. So when I aligned it to something else. I think I aligned it to Rigel. Rigel is gonna be fine. So here's what we're gonna do. We're going to say back and menu. I'm going to sync to the target, sync to the moon, enter. It's gonna be good enough for I'm not terribly worried. Instead, we're gonna jump over to I'm gonna turn the lights on just a little bit better. We're gonna go over to Sirius. No, we're gonna go to Rigel. All right, menu. All right. So select and sync. We're going to go to stars and name stars, and we're going to go to Rigel. So Rigel is a star. It is the foot of Orion. Almost Rigel, and we're not going to Rigel Centaurus. Just going to Rigel. Okay. So last night I actually did the polar alignment. And everything, and that came out really nice. I just can't believe I have my view camera flipped over, so I can actually fix it now. That won't take very long. We are going to, well, let's see. Start night. You can see it's going through something. What are we looking at? Uh-oh. Well, good thing I did that. It almost caught my jacket. So we're seeing some stars whiz by, and remember we're on a 4-second exposure on this one. Yeah, 4 seconds. So it's kind of it's doing its thing. You can see that in the background there. There we go. So now we're looking at something. There we go. Now we're looking at Orion. It's upside down. It's fine. But here is Rigel. So I'm going to go and I'm going to flip this the other way around. Let's go ahead and leave the live view on. This, so I have this on a, I don't know if you can see, probably not well. Not so easy to do when your fingers are cold. Right. Close. So luckily this camera has a 1/4-inch thingy, kind of, yeah, has a 1/4-inch threading on the back. Makes this really easy to do. Thing. What's that? Those trees in the bottom? I believe those are trees at the bottom. hoping those are... No. I did the same thing again, didn't I? Maybe. Maybe. All right. Okay. You know what? Hang on. Let me think. Which way is... It doesn't matter. We'll leave it as it is. If I have to modify it, I'll modify it. So here's what we're looking at. This is Orion. And on a 4-second exposure, let's pump that up to 8 seconds. So again, we are in the light polluted skies of the city. We're kind of off to the edge, but still have a bit of light pollution. So even so, with an 8-second exposure, using an old repurposed uh, television lens, it's like it's literally tiny lens. It's not very big at all. We're able to pick up this much detail, and this is a really, really wide angle view. I think right now I have it on. It doesn't really matter what it is. It's just really wide angle, so we can see all of Orion. It's not in great focus because these lenses were not made for high definition cameras. They weren't made for CCDs, for astronomical CCDs at all. These are like surplus that are used for security cameras. Um, and back when this thing was first made, everything was what, 1080i? It was not 1080i. Was it 480? 480i? Yeah. So old scanline television stuff. So the quality is not going to be great. Even so, just by looking at this, we see a lot of stars come in. We can see the Orion Nebula right there. There's actually color to that. I don't know how well you can tell, but there's actually color. I'm going to flip this over from RAW 8. We're going to go RGB 24. I want something a little bit better. It's trying to pick up a focuser that I don't have connected. That focuser goes to the camera. So I'm going to zoom in. Let's go. 300% is fine. So you can see the stars are not terribly round, but we're getting a lot of them. And right there, actually seeing a little bit of color in the nebula. It's not a whole lot, but it's there, it's visible. So we're able to pick that up. And we're able just to pick up a ton of stars all around. We've got the, what is it? A Horsehead Nebula and Flame Nebula right over here. We're not going to be able to pick those up with this camera. And not this way in the city. So just for kicks and grins, I'm going to take this up to 12 seconds. Let's see what happens. So the frame is coming in. You can see down here in the lower right hand corner our progress bar. See just how fast it comes in. 11, 12 seconds. What's it going to look like? Download. Oh, it's doing this thing again. Oh, I had an issue with this last night where it just was not updating. I don't know why, but that's fine. Let's do RAW 16, see if there's any difference. I ended up just having to shut down the application and bring it back up. Let's see. Any difference? Anything at all? It should be noticeably brighter. No, and now it's messing up completely. So yeah, it's not doing its thing. All right. Kill that. Start it right back up again. All right. So we know where it is. We know we're pointed at roughly the right direction, the right area. And I swear I must have put the camera upside down yet again. I guess I wasn't paying attention. We're going to jump over to this one camera because what I'm going to do is go back down 25%. Do not see Rigel in the field of view, so we're going to go get another camera. This is the guide camera. That's just going to drive me nuts. I don't see anything in the guide camera. Anything at all? Anything at all? No. I don't know why it's not picking it up. Oh, lovely. Yeah, it's not one thing, it's another, right? I'm going to jump onto a different one. Let's see. We're going to go to... yeah, it's not going to work. this isn't going to work at all. Well, that's not good. All right. We're kind of, well, I'm kind of stuck now. Oh, that's not good. All right. Let's see what happens if I go back to this one. I don't think I need a reboot. Hope I don't have to reboot. See, 100%. Yeah, it's not, man, it's not one thing, it's another. There we go, 5 seconds. Oh, there's something else going on. See, it's not even able to pull it in. Okay, I'm gonna have to kill it. Here. Kill it completely. Okay, well, that's not good. Go on different application and see if I can pull it in. No, can't connect on that one either. Well, this ain't good. All right, next PhD. PhD usually should be able to pick it up. So this is my guiding application. I'm gonna go, yeah, say, I'm gonna pick which camera it is. That's the one we want. Connect to it. Connect to that. Good. And looping. Okay, we are close, but not quite where we want to be. Therefore, let's see. So we have a 1 second window. 2, 3. Nope, wrong direction. Okay, that's something. Still wrong direction. There we go. Okay. Close. Okay, I'm going to slow that down this way. So what we're looking at right now is Rigel. Hoping we're looking at Rigel. And we'll recenter. Okay, wrong direction for that, and back down. So I want to get close to it so that now, just try sharp cap again. Let that do its thing. So we have a 1 second exposure, and I will do this. So for guiding, what we want to do is, what I always do is I clear the calibration data, because I'm never certain it's going to be right. We can't guide off something that big and bright. We have to do something a lot more dim. So I'm going to pick up that camera. Please work. There we go. All right. So what are we looking at? We're looking at Rigel. The reason why I want to get to Rigel is that's it right there. I need a slightly longer exposure. We're going to go RGB 24. So we want full color for this. Doesn't really matter, but it is what it is. I want a little bit longer of an exposure. So I want it brighter, significantly brighter, really. And let's go 25 because I want to center this out. Once it's centered, then I know that, okay, direction. When it's centered, I can go ahead and do the realignment. And that's what I want to do. There, now there. There we go. So we're centering. I know it's kind of boring. All right, so let me go back to the questions if there's anything going on. There we go. There we go. There we go. Orion Nebula on tonight's target list from Bill Adams. Yes, of course Orion Nebula is going to be on the target list. We're getting in that area right now. And I want to do some really, really cool stuff, specifically with spectroscopy and the Orion Nebula. But first, we have to get stuff in focus. And the reason why I say that is sync to Rigel, enter, enter. Now we're synced. Okay, so Rigel is now center view. Rigel is not in focus. I will zoom in and show it to you. See, that is not an in focus star. Not really. I'm going to turn up the gain. I'm going to blow this thing way up. It is not in focus. Here's what we're going to do. We're going to get this thing in focus. And the way we do it is with what's called a Bahtinov mask. This is a Bahtinov mask. It's kind of hard to see. There we go. If I have... oh, I know what I can do. This is a Bahtinov mask. This is one I use for the bigger telescope. What this is, it is a nifty tool to use a quantum mechanical effect of light in order to get a good focus. What's happening here is we're splitting up the starlight and forcing it to behave as a wave and not just a particle. And by doing that, we get to a good focus. And that is one mask, and this is my smaller one. So we're going to put the smaller one on and show you just how to get this thing in focus. That literally drops down in the very, very front of the telescope. Okay, how's that? Do you see these patterns? These patterns, I'm going to turn off auto, and I'm going to bump up the gain massively. You see these spikes? These spikes are what we're looking at to get a good focus. When they're symmetrical, this telescope and camera will be in focus. And what I want to do is the Bahtinov mask tool. And this is a nifty little tool that analyzes... What, seriously? Turning up the black level. All right, fine. This is usually... let's see. There we go. Turn this down just a tad. A bit more, down to 8. Sure, let's see what happens. Okay. So it is actually trying to calculate these lines out and see just where they are. Anything? 8. Gonna want to keep it at 8. And see, I don't think it's quite right. So I'm actually going to disable this thing. I'm going to do it. I'm going to do it with the old eyeball Mark 1. So I'm going to turn off this tool. Usually this works out pretty well, but right now it's kind of iffy. So what I want is this to be as symmetrical as possible. Right now you can see this is a little bit over too far to the right. So I need this to be right smack in the middle. Do that is change your focus. I need to mark where it is right now and move it just a tiny bit over. Is that good? Is that bad? That's too much. Move it back. That right there is pretty good. That's not bad right there. So just as a quick test, rotate the mask. Let it settle out. And there we go. This telescope right now, this telescope is in focus right now. So that's exactly what we want to see. I'm going to, what else can we do? Yeah, so this one's good. All right, cool. And then the next one, actually I have the other one telescope too. All right, let's see what happens. I'm just gonna do this. We're gonna zoom out, zoom back 10%. So there we go. That's kind of what I want to see. I'm gonna go back down 25%. Okay, and I'm gonna pull off the mask because we don't need it anymore. At least not until the temperature drops down further. Now, as the temperature does drop, the telescope will actually shrink. The tube will come down just a couple of millimeters, but it's enough that stars right now that are in focus will be out of focus in another 2-3 hours. Temperature's dropping that fast. So what we do is we just have to refocus every hour, so every half hour. In automated systems, there are actually telescopes that will go ahead and refocus after every single image. So I'm gonna do a 4-second exposure. I want to see what's in this area. So 4 seconds. How many stars we're looking at? So we have Rigel, which is a bright blue star, and there we go. So we have Rigel there, and I'm gonna do this. I'm hoping this is gonna work. So this is live camera. I haven't tried this before. It's not the camera I want. We're gonna take. I gotta find which camera this is. Camera. This is not the camera I need. Um, uh, it's not the camera I need. I need something else. So this is. Where is it? Calibrate options. Create video preview. Let's see. Don't see. I don't see which camera this is. I don't see how to pick the camera yet. Well, that's not good. Live camera. No. It's not what I want. Live camera. It's not the right camera. It's not the right one. I want to do the right camera. I don't want to keep looking at myself like this. What's the camera input? Open. Maybe. Oh, here we go. Oh. Ooh. No, it won't let me do that then. Ah, yeah. Direct show. Oh, man. Okay. I did not go to direct show. Oh, and we're having an issue again with that. Oh man. Okay. All right, we're gonna have to do something else. That's okay. We're gonna go this way. So we're gonna do nope, 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 nope. We're gonna do it with an image file. Not right this moment. Um, what I want to do is I want to pull out the light from Rigel. So there's something kind of cool. Let's see, any questions? All right. Okay, so we're going to do this. We're going to switch cameras. Hoping this will work. Let's see just how well this will work. There we go. So we're going to pull this one in. And do a lot of switching between cameras. 25%, that's fine. Close. And I want a much longer exposure. Let's do 4 seconds. It's right there. That's what I want to see. That's what I want to see. Except for the fact that I also want to see that in focus. It ain't in focus right now. So let's get the Batinov mask on the other telescope and get that one. Fortunately, I don't have to get up for that one. Okay. So we got a Batinov mask. All right. Let's go zooming in. That's probably too much. Let's figure out where we're at first. 200%. Down here. There we go. Cool. So what we're looking at is the out of focus spectrum coming from the star. Okay. And I need, what are we going to do? 4 seconds is way too long. I need something way down. And gain, I want to bump, there we go. Gain has got to go way up. Okay, so this is a 1 second exposure. I want it faster. I want lots of gain. Come on, there we go. Is it ugly or what? Get this one in focus. So rotate this direction. Is that better or worse? Just so much worse. Okay, we're gonna pull it back. Oh, come on. Okay. Go. Have an update. Almost there. This is a black and white camera. Almost there. Yes, this is what astronomy is like. It's fiddling with the focus until you get it right. A little bit more. It's getting there. It's almost there. I swear, it's like oh, oh. Well, that would explain it. I'm at the very end of my focus. It will not go any further, so I've got to do almost there. Okay, well, fix that. I'll be back again. See how close we are. I have to let it settle. Oh, it's still at 4 seconds. I don't want 4 seconds. I'll do 1 second. Okay, so we've gone way past where we want to be. 1 second is too much. See what that's going to be like. Ah, not what I want. I need a little bit more than that. Okay, now I can pull in the focus. Get there. It's not exactly real time, but it's getting there. It's pretty good. We're close. Almost. Almost. Just about. Okay. Let it update. Come on, update. Okay. A little bit more. And that is pretty good. I'm going to say that that's close enough, isn't it? I think that's close enough. All right. Take the Batinov mask off. And now we've got a star. A fairly fast exposure. We're going to do this. We're going to go out to 100%. What are we looking at? We're looking at a spectrum. Way too much gain. Okay. What I want to be able to do is see intensity levels in there. So we're going to kill the gain. We're going to drop the gain way down to nothing. No gain on this thing. I want as raw as I can get. There we go. Okay. But I need a little bit longer of an exposure. We're going to pull this thing down. We're going to do, let's start with 1 second of exposure. So what I have on here is a diffraction grating. I think of it as it is a piece of plastic or piece of glass that has little lines scratched into the surface, but they're very, very fine. They're very, very close together. It can be on the order of several hundred to thousands of these lines in an inch. What that does is, as light passes through, it's spread out into a spectrum. So what we're seeing on this end is blue. What we're seeing on the far end is red. Now you can barely see right through here some drops. So there's probably additional drops in here. It's really hard for our eye to see, but I want to see if I can get it. I'm going to try to play with this and get it down a little bit more because I don't want this to be totally up. I want this to be a little bit down. This is not too bad. Okay, so here's what I'm going to do. I'm going to do a quick capture. I don't want a quick capture. Capturing one frame. I really need to call this thing something that I can understand. Rigel underscore, let's call it spectrum. So it is not in color, it is black and white because this is a monochrome camera and I don't want any, we want to do this kind of stuff in black and white because that gives us everything that we can see. And actually what we're seeing here is a little bit into the ultraviolet and we're seeing a little bit into the infrared there. So it's, the camera is able to pick it up even though our eyes can't. So we want to get that additional data. I'm going to do stop capture, 17 frames. Oh, I did not want that. I did not want a video file. What I wanted is mono 16 because I want more data. I want as much data as I can. And do that, mono 16. And we have that exposure there. That's not too bad. Okay. And instead of an SCR, which is a type of video file, I want to do a TIFF. And let's do that. Let's do start capture. Actually, maybe we'll do less than that. What if I do here? Will let me do it. Close. Yeah, it will. Go. That's what I want. Let's see how big it is. Nope, I want a little bit more. Nope, gotta have a little bit more than that. So, but that's not too bad. No, that's not bad at all. So what I'm doing is I'm saying don't use the entire sensor, just use a portion of the sensor. Because I don't need all that data. I just need some of it. So I will do zoom, I'll do 25% because I want to make sure that I have everything in the same image. There we go. So this is what I'm pulling out. I want the star and I want the spectrum. I don't care about anything else. I just want the star and the spectrum. We'll actually be able to play with this a little bit differently once we hit the Orion Nebula. Ooh, it's getting cold. I have no gloves. I'll probably end up putting my jacket on in just a few minutes. But actually, I have a hat underneath this, and then the hoodie on top. And it is still getting chilly. Okay, so we got this. I'm going to do a quick capture. I really just want like one frame. I really just want one frame. What do we have? Oh, we have ISS coming overhead in 5 minutes. Where? No, it's going to be in the west. I can't see it from here, and it will be visible for a couple of seconds, very, very low in the sky. So if you want to, in 4 minutes, you can go look at the west. It's just north of west, and it's very, very low in the sky. So unless you have a clear western horizon, you're not gonna be able to see it. It's really too bad. It would have been nice to have seen it up higher. We could have done something with it. So I want a single frame, Rigel spectrum, start. That's all I want. One frame. Go. Be able to open this thing up. That's what I want right there. So let's see how well this is going to work because I have not done this before. We're going to do image file. Open there, Rigel spectrum. Okay, there we go. So now we're going to go to rotate because I want to rotate this thing so it's jar. Too much, too much, too much, too much, too much, too much, too much. Right about there. We want it as straight as possible here. As straight as possible. All right. That's good. Okay. And then let's bring this down. Right about to there. Okay. That's not bad. That's not bad. Okay, so now I have to calibrate this. So calibration. Oh, let's see, where's the calibration? We calibrate it. First pixel. So click on pixel 1, image. So we're zooming in there. That's max. Yep. And that's 0. The 1 point alignment we're going to do. No, we're not going to do 1 point. We have to do 2 point. Ooh, but this is going to be kind of hard to see. Oops, minus, plus, plus, plus. Scroll down. So what I'm looking for, there we go. Okay. What we're looking through here, and it'd be easier if we use like Vega, because it's a type A star. I'm looking for hydrogen lines, okay, to do the calibration. And this could be it right there. This actually looks like it. So there are things called the Balmer lines, and those are basically the lines of hydrogen absorption in stars. So it's hydrogen alpha, hydrogen beta, and a whole bunch of others. And that's what we're kind of looking for right now. So I think this is it right here. So here's what I'm going to do. I'm going to come here and I'm going to say, okay, that right there, we're going to call that, yeah, right there. And we're going to call this hydrogen beta, which is 4861 angstroms. And we're going to say apply. Okay. I could probably do a lot longer of an exposure just so we can get this up higher. But let's see. Let's go ahead and close this calibration. So right now we have this in angstroms, and this looks just about right. I'm going to come in and zoom in on here. So what we're looking at right now is, well, really the spectrum of the of the uh, uh, of the star. So that's actually kind of cool. We're actually able to see different absorption lines. And I'm going to go reference, not reference. Where is it? Appearance. No, not appearance. Where is it? No, I haven't messed with this before. So that's what's going on. I'm trying to find where the show the measurement lines. No, those are good. There's actually a tool on here, and I'm trying to find where it is. That lets me do open reference series. Nope, that's not what I want. Geez, now I forgot what I'm looking at. Appearance. No, not appearance. Not the calibration. There is a. Where is it? Where is it? Elements. That's what I'm looking for. Elements. Okay. So what are we looking for? Is this a type A star? It does not look like a type A star. Um, whoops. Apparently I put in typo saying, oh, 2020. Whoops. Oh, my wife just texted me saying that um, I have 2020 on the date for this instead of 2021. Oops. Terribly sorry. So I'll fix it in post. How's that? All right, let's see if any other questions. No. Okay. All right. Okay. So Rigel is not a type A star. Okay. So if we're looking at this, we should be seeing all through here these various absorption lines, and we're not seeing it. Okay. We're not seeing any dips here. So we can go to type B star. Doesn't look like a type B. Type O does not look like a type O. Type M. No, that's closer, but I don't think this is type M. Type K. Ooh, that's interesting. Let's see. There we go. Maybe we have some dips through here. Doesn't account for these here. It's not a type G. Maybe type F. No. We'll have to find out what it is. But I'm going to look at hydrogen Balmer sequence and see how close I am on this. So these are lines. I have one line. You know what? I don't think my calibration is right. I don't think my calibration is right. So I can fix that because that's close. But I should be seeing other dips. And I'm not. So I may need to take longer exposure. That may actually help. Um, that's actually, that is kind of cool. I'm able to actually see these little dips. I wonder what this one is here. So wherever we see something like this, a dip down, that means there's something in the atmosphere of the star that's actually absorbing um, the basically the energy. So I'm able to come through here and we can see comets. So comets are going to have dips in here. Carbon star. Oh, is it a carbon star? I don't think Rigel's a carbon star. But we got a dip right there. We got a dip right there. That's close to a dip. That's close to that dip right there. That's interesting. What line is this? C2. Oh, that's interesting. So we have carbon 2 in the atmosphere of Rigel? Maybe. Hmm. That's kind of interesting. That's actually cool. Okay, so I want to see. We're going to do this. We're going to go actually look at Rigel. Okay, where's Rigel? Double star, apparent magnitude, description. Tell me what it is. Rigel is a supergiant, so it's a class B. It's a B8. Okay, let's go back here. Let's type B star. Get rid of carbon stars and type B. So, whoops, back to here. So I don't think my calibration is right. I don't think I'm looking at the right thing. Because I only have this one, but I should be seeing these dips across. Okay, so we can change the calibration. And there is a nonlinear. Where is... No, that's not where it is. Hmm. Yeah, I have to play with this a lot more. And I think I need a much longer exposure so I can get more data in here. But for now, we can actually see something kind of cool. And again, this is the very first time I'm playing with this. So I think that's actually pretty cool. We were actually pulling in real data just looking at this star. So uh, yeah, that's pretty cool. Let's see. We have some of our club members online talking about going out to the dark sky site and talking about equipment. It's always interesting. My hands are just getting so cold. I really need to. I wish this one had pockets, but it doesn't. So just kind of have to freeze. Um, let's do this. Let's go ahead and swing it over to Orion Nebula. We got Sharp Cap on here. We're still getting a live image. But just for kicks and grins, I'm gonna bump this up to a much larger one. Longer, longer, longer. And I need to look at my histogram too. Histogram looks okay. Let's see what happens if I do auto stretch. Whoa, whoa! Look at that. That's a whole lot of data. Um, there's more data there. There's more data there. Look, if I do this, this stretches it out a whole lot in this direction. So if there's more data, we can actually do something with it. Okay, all right. So I'm gonna have to do this now. Let's check out the exposure. This needs to be a little bit more in that direction. Yeah. All right. Let's just do a quick capture. Nope. Nope. Let's see what happens. I'm going to bring it up in here. We're going to open a new file. Um, I did not find one. There it goes. Ah, pulled out a whole sequence. It's still pulling out new files. How about I stop? Stop capture. I don't need so many. I don't need 30 frames. I just really just wanted the one. Okay. See what happens when we got this now. Oh, zoom out. Okay, I should be able to capture a lot more data. All right. This means that I'm just not capturing enough data. I should have longer exposure. Go LX mode. Um, let's just do, I don't even know. See how I have the 4-second exposure. I have no idea. But let's see what happens. So again, what we're doing right now is we're taking the light from a star and we're spreading it out into a spectrum. We're saying, I want to see everything from red to blue, actually from ultraviolet to infrared on this star, and I want to see what it's doing. So let's do this. I'm going to do single frame. I'm just going to do just single frame. I don't need so many. 2, right? Open. I think we need to go here. 2, 1, it's 2, yeah. Okay. Just grab it this way. And it's still, excuse me, it is still, I think I can still get more data out of it. I could go for longer exposure, but what we're seeing, well, maybe not. Excuse me. Um, I don't think my exposure is quite right. I don't know where it should be. We're seeing some data, some drops right here. This corresponds probably to that one right there. Maybe that one. It's kind of hard to tell. I think I need to play with this more. I think I definitely need to play with this more. The previous image, actually, I think the data was a little bit easier to see. Um, but, well, we're still getting drops here. We're still actually getting drops. So, I don't know. And if you look at the light, this is the blue end, this is the red end. So Rigel is a bright blue supergiant. So we're seeing more light over here shifted in blue, in the blue direction than we did in the red direction. Huh. Well, that's just neat. But I think we need to jump over to the Orion Nebula. I think it's time. Anyone else? I think that's actually pretty cool. That's actually really interesting. So I'm going to play with that some more, and actually, and the Orion Nebula might be able to play with that a little bit. All right, let's see what happens. Back menu. I'm going to do select and slew. We're going to go deep sky again. Named objects. Whew. I swear my fingers are just. We're going to go to Orion Nebula. And oh. There we go, Orion Nebula. And it's pretty close, so it's a rather quick slew. I'm going to switch to a different camera. Close. There we go. The Orion Nebula, right there. Isn't that fantastic? We are actually looking at the Orion Nebula. We're looking right there into the core of the nebula. You can see a tiny little bit of nebulosity around there, and if I zoom in, because at 25%, we're going to go in way close. That right there is the trapezium. So this is, there are actually like 7 or 8 stars right here. We're able to pick out 1, 2, 3, 4. There's actually one more right there, and there's a couple more through here, but they're very, very dim. If we take a much longer exposure, we can actually pick some more out probably. Hey, there we go. Now we have a little bit of nebulosity that's coming in. So this is a 200 millisecond exposure. Is it 1/5 of a second? So it's very, very fast, but we still are able to pull out a little bit of detail. Not very much, but that is expected. Just for kicks and grins, what I'm going to do now is we're going to play with the histogram. We're going to do auto stretch, which gives us a horrible, just terrible, absolutely awful image. It's grainy, it's noisy, but all we're doing right now, we're taking the data that we have and we're stretching the histogram to pull out as much as we can, but it just looks bad. How do we fix it? We take a much longer exposure. 1/5 of a second is not good enough. It's nowhere near good enough. So we're going to go to 4-second exposure. And we're just going to keep building up. We're just going to keep going, and we're going to see what's going on. There we are. Now we have the Orion Nebula. And we have it in a 4-second exposure. That's it. This is just 4 seconds. And if we do the histogram stretch again, get more detail out of it. So, excuse me, you see a lot of noise. It's really, really a grainy image, but it's only a 4-second exposure. That's not bad at all. And I'm going to see if I can get it a little bit better. Cooler on and chill down. Chip. Here we go. So we have a 4-second exposure with a lot of noise because we have the histogram getting stretched out. What that means is that, so I'm going to reset it. We get a lot of black and a little bit of white, and then there's stuff in between. The histogram tells us basically how many photons we're getting at different levels. Like basically, you can think of it as if you take all of the pixels, this kind of maps out how many have 0 photons and how many have what's called a full well, as in it is completely packed. It is recorded all the photons that it can record, which is basically means white. Ooh, the streak. We got a satellite. We got a satellite. Look at that, right through the Orion Nebula. Let's gonna let that thing pass through. So this is how much that satellite moves in 4 seconds. I didn't think we'd catch a satellite, but nonetheless, there we go. So we managed to pick up a, a satellite going right through the Orion Nebula. And while that thing's going, I'm going to see on here really fast. Can we see what satellite that is? Sometimes this will go ahead and tell us. If I do label satellites. I don't see. Sometimes it'll tell us. I don't think I've updated the Inverus enough to know. No, I don't see any satellites, which is too bad. But it's passing right through there. So this is a pretty slow moving satellite too. This is not the space station. This is a fairly dim satellite. You could probably see it through a telescope. All right, we're looking through a telescope right now. You can see through the telescope. So that's neat. Let's see, anyone else? I don't see any other questions. Again, if you have any questions, any comments, concerns, if you have any questions about the Astronomy Club, you can go ahead and put them in the chat, and some of our other club members will go ahead and answer them. If you have any questions for me, anything you'd like to see in particular, let me know. I will take a much longer exposure. We will make the Orion Nebula look a whole lot nicer. Right now, I just still want to see the satellite just pass through. It'll pass through momentarily. This is actually something that ruins images. So if I had taken right off the bat called a 4-minute exposure to get a really nice Orion Nebula, that would be just one long streak through the image, and we would just toss it out. We would call that a subframe or sub-exposure, and it's one exposure that we take out of the entire sequence of images, and we'd have to throw this one out because we got a big line going through it, and it's kind of hard to delete that kind of data easily. I know there's some algorithms with PixInsight that can do it, and if you stack all the data and average it out, yeah, it'll disappear to a degree. But typically, if we see a big old streak through there, we just toss it. It's almost out of there. So, all right. So we're gonna take a much longer exposure. I'm gonna, instead of doing a 4-second exposure, let's just do a 15-second exposure. And I think the gain, yeah, I'm gonna take the gain. I'm gonna drop the gain down to nothing. Nope, sorry, it was way high. I'm gonna take the gain and drop it down to nothing again. But I need to do keeps bugging me. I do RGB 24. Yeah, we'll do RGB 24. Oops, I didn't want to copy it. I'm going to close it. So 15-second exposure, it's going, and RGB 24 with 0 gain. Gain's not quite like ISO. What gain does, it just you can think of it as just adding to every single pixel on there. It's adding some amount. It's kind of like a histogram stretch, not exactly. It's a little bit different. But you can see right now I've done a 15-second exposure, and we're back down to showing very little. I'm going to jump in 100%. We can see the trapezium again, so we're not doing any gain. What we have to do first, if we're going to do a decent exposure, we're going to have to start guiding. So right now I'm doing calibration with PhD, and what that is, PhD is a nifty little program. It stands for Push Here Dummy. And what you do is you hook up a camera with a little small telescope on it, your guide scope and guide camera. You run it through the application, and you tell it to calibrate itself. It goes ahead and does a calibration. What that means is it pushes left, right, up, and down, or declination and right ascension on a equatorial mount like this. It pushes a little bit here, pushes a little bit there, and then it watches the the star in the image to see where the star goes. And then it knows exactly how much to push the camera or to push the entire mount in this way or that way to keep that star centered. I want this star as close to there as possible. So we want the graph here to be very, very small. And that's what I want to see. Okay, now we're guiding. It's good. Now we can come back to here and say, okay, I'm going to do a little bit more than a 50-second exposure. I'm going to do a, let's say, 60-second exposure with no gain. I want it as raw as possible. I just want to see what it looks like, and then we can push up the gain. We can see just how much detail we're pulling out. But I want to see what we'll see in 45 seconds. Probably should not be out here. I cough in this weather. But it's fine. It's only 8:30. Only been doing this an hour and a half. Plenty of time. Okay. Let's see. Questions. I don't see any questions. We have a question from Christian about joining. If you go to the Facebook page, there is a set of directions on there on exactly how to join the club, from paying dues online to getting the material. Ooh, 6 seconds left. I could put on gloves, but if I put on gloves, I won't be able to actually use the computers. So all I have is big old ski gloves. So that's not going to work. All right. So what are we looking at? We're looking at the trapezium, right smack there in the middle. The trapezium is a group of hot young stars throwing off a ton of ultraviolet radiation. And so that ultraviolet radiation is lighting up the hydrogen and the oxygen and a little bit of sulfur in the nebula, in the Orion Nebula, and causing it to glow. And that's where we get the colors from. That's where we get, just viewing it is from all that ultraviolet radiation. The hydrogen absorbs ultraviolet light, goes up a level, hydrogen alpha, and then drops back down in energy level and releases a red photon. So absorbs high energy, releases lower energy. Oxygen, sulfur do the same thing. So sulfur at second energy level, and oxygen is the third energy level. It absorbs, oxygen will absorb that ultraviolet light, jump up to a third energy level, drop down again to the base level, and release a blue-green photon. So again, energy is absorbed and then released, and not cleanly. So what are we looking at? We're looking at just the very, very center. And if you look through a telescope, this isn't going to be different than what you're going to see with your eye. The bigger the telescope, the more you're going to be able to see, but it's still going to be this hazy spot. So this is a histogram stretch. Let's see what the histogram stretch does. So I'm going to drop this down to 40%. Yeah. So this ain't pretty either. What does this tell me? This tells me that there's a whole lot more data that we really need. So I'm going to take the the gain, and we're going to push the gain way up. Because, well, y'all want to see it look nice. So looking at that, this is great for astrophotography, because I have a lot of data in there, even for just a 60-second exposure. But I had to have to do a lot of processing. So I would take this image, and I would take a bunch of other images, and then piece all those images together, stack them basically in the vernacular, and then I'd be able to start pulling data out. I'd be able to play with the levels, play with the curves, bring out the brights more and the mids, and then make sure I don't lose data, because if everything goes to white, that means you're losing data. You don't want to have fully exposed images. And the exposure in astronomical terms is different than exposure in photography terms. If you say you want a fully exposed image, or a nicely exposed image at least, with photography, that means it's going to be the same thing though, where you don't have a bunch of white and you don't have a bunch of black, everything is in the middle. That's what we're trying to focus in on here too. So it's a 60-second exposure, and with the gain turned up, I've totally blown out the inside core. It's just white. It ain't pretty. Let's do histogram stretch. What more detail can we get? But the dim stuff, I'm picking it up now. So I'm able to pick up over here. We have some dust bands. We have the major dust bands all through here. This nebula is coming out. We're getting color. We're getting these whirls through here. The wings of the Orion Nebula. Um, Getting a lot of detail through here. We have the Running Man. The Running Man Nebula has come in. So we're able to see this now by upping the gain and playing with the histogram. But it looks grainy, it looks noisy, because it is. So if I zoom way in, I got nice round stars. So my tracking is pretty good, but there's just so much noise through here, and I don't want that. So what I'm going to have to do, there's no other way around it, is just do a much longer exposure. So I'm going to do what I did yesterday. I think I did a 4-minute exposure. I'll do a 4-minute exposure, but I'll cut the gain down just a tad. See what happens. So 4 minutes. We'll let that thing go, and we can talk about other stuff. Let's see. So John, M45, Tiger Eye, NGC, Flaming Star, All Things Orion, Rosette. Oh no, Christian's asking John what he was doing, I guess. Maybe. We'll see. Okay. There's a lot of stuff that we can see. We still have plenty of time. But I am getting cold, so I will be putting on a jacket. On the plus side, tonight looks like it's going to be a dry night. I don't think we're going to get any dew. The dew point's going to be well below freezing. So, that is nice. Putting a cold jacket on, not too much to warm you up. So, hopefully. You know what? I think this jacket is a little bit tight for having so many layers underneath. So I'm gonna have to put on a different jacket. Let's see. So what are we doing? I'm gonna. And luckily, I know exactly where my jacket is. It's just inside the door. So here's what we got. This is with a quick exposure. It's a very, very quick exposure. And then the gain is 290. That should be fine. The histogram, I think we have a default. Yeah. Nope, there's a default one. So this is stretched. Yeah, this is regular histogram. Good. This is kind of what I want to see. But we still have another 2 minutes, 14 seconds. I'm going to go grab another jacket. So I'll be right back in just a moment. Fortunately, this one is much warmer, and it has these hand-warming pockets that are nice and soft. Oh, I'll kill my light. I didn't want to fall into the pool, so I had to turn on the light. I am actually very, very close to the pool, so I kind of have to be careful as I'm coming around the edge of the table. How much more? 1 minute, 11 seconds. This is not bad. Not bad at all. So we'll see what happens with a 4-minute exposure. We should be able to get a whole lot more data out of it. Right now, even with this short one, you can see we have a lot of stars. We can see the little reflection nebula, or not reflection, you can see the little side nebula. I forget which one, what that one's called. Let's find out. So here's what we're getting pictures of. I really don't like this image. I think this could be better. But here's the core of the Orion Nebula. Here's that reflection nebula off to the side, I think. Is that the Running Man? No, this is supposed to be the Running Man. That's the Running Man over here. So, I don't know. We'll see that. This is that side star that we're getting that nebula off of. I really don't like this image. I should probably just upload one of my own. or just get a different one somewhere else. All right, we got another 4 seconds. This should be a fast download. Any second now. Oh yeah. Huh. That's that's actually a lot of detail. So this is all blown out. I'm not really concerned about that, especially for right now. This is what I want to see. We're seeing a lot of data through here. A little bit more of the Running Man. Seeing the dark banding through here. This isn't bad. I would be playing with this a lot more. I would drop the gain way down. Actually, that's probably what I should do is drop the gain way down. Then play with the histogram. So if I was going to do imaging for myself, I'd be taking a lot of images, but I would be doing it with gain way down, probably longer exposure, probably a 5-minute exposure, maybe. This is a small telescope, and then going from there. Um, yeah, that's not bad. It's pretty. We can see a lot of the red through here. So, all right. That's not bad. So I'm actually having to look at another monitor which has better color rendering than my laptop screen. Laptops typically don't have really good color rendering, but I didn't want to spend a whole lot of money on a laptop just for that, which I guess I'm kind of paying for it now. You pay for it one way or the other, but this is a nice one because the keys light up, so it's perfect for astrophotography. It's not red, that'd be even better, but I don't want to pay that much for a gaming computer with the multicolor LED keyboards. I don't need that. I do have a second monitor on here, and on the second monitor, I can take PhD and dump it over here so I can watch the guiding. I can make sure my guiding is good. It's not great, but it's not, actually, it's not bad. It's not bad. RMS error is not bad at all. Okay. So at least we're keeping with the nice round stars. It's got another 2 minutes before. Yeah, 2 minutes more. We're picking up a lot of detail. I'm actually pretty happy with this. So this is an apochromatic refractor. It's TeleVue 101. So the white one in the back, and we're actually able to get some good data off of it. It's it's a fairly flat field. I have a field flattener, and I forgot to attach it to the camera. Oh well. So that could have flattened it a little bit more and give me a little bit wider angle of image, but I'm actually okay with this because I want to get the Running Man. So if I do the histogram stretch, auto stretch, yeah, we can see the Running Man a little bit better through here. The head is here, supposed to have like 2 arms, and then the legs going down like that. This is upside down, but we're all getting some detail through here. The dust bands are really cool. So I'm actually okay with that. And we see just a lot of white through here, so it is overexposed, even through here, and that's because the gain is so high. So, and Orion Nebula is a really bright object too. So it's the core is almost always going to be overexposed. You really have to do some really specific types of imaging in order to not get a overexposed core. You have to basically it's layering images and it's doing things like masking where kind of you block off an area of the middle and you say I don't want to increase the gain essentially. I don't want to change the levels in here too much. I want to change them by a different amount. So you brighten up the outside, you can dim the inside, and you get that HDR type of image look to it, which some people really like, some people don't. So here's what we got. This is 4 minutes, no gain. But this is kind of important because it does give us some additional information. So I'm going to jump in. Excuse me. Stars look good. We have dark regions. Trapezium is still in there, which means we still have good data. If I do a stretch, back out to 25%, so we can see everything. So the Running Man kind of goes away. This is not nearly as overexposed as it was before. So that's actually good. We're getting detail through here. We're getting detail through here. This is all blue, but it is what it is. So I'm not worried too much about about that. This is, and remember, if I was going to be really going for imaging, I would not be doing it from my backyard in full color like this. I would be going down to Grandview and I'd be doing it from there, or I'd be going out to one of our dark sky sites. So I'm not dealing with light pollution. I do not have, wait, yeah, I do. I do have a light pollution filter on here, so it does block some of the light, um, everything. I want the nebula to come through so I can do a 4-minute exposure without everything being blown out. I want to see, can I do, I don't think I can do multiple copies of Sharp Cap at the same time, can I? I may be able to. So, I don't know how well this is going to work. We're about to find out. Unless it crashes the whole computer, which is entirely possible. Seems to be okay so far. And I'm going to do a 8-second exposure. Ah, always forget. RGB 24. I'm going to have to just get rid of that completely. 8-second exposure. Still going. No. No, 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 no. It does not like that. It does not like me doing imaging from 2 different cameras at the same time. Not at all. That sucks. I was really hoping that this would work. What I was trying to do is actually show what we're looking at in the sky at the same time while we're doing that imaging, and it's just not going to cooperate. Yeah, this is just going and going. Maybe, 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 maybe. Negative. Does not like that at all. Okay, well, that's not going to work. I'm trying to do something, but it's just not working. I hope I didn't kill this. We'll find out in another minute. So that's the Orion Nebula, and I'm going to swing it over to the Horsehead. I have not done imaging of the Horsehead in a while, but this is looking so nice that we may be able to pick something out. The Horsehead's kind of a hard target. It is a hydrogen beta nebula, so it's different than hydrogen alpha. It's a different color of red light, and it is pretty dim. I've seen it once through a telescope eyepiece in a very dark location. And I think it was, oh, where was it? I have no idea. I don't remember where it was. But I think it was through either 24. I want to say it was either 24. I think it was a 24-inch telescope, 24-inch Dobsonian. So it was a big one. See what it looks like. Okay, not really any different. Okay, that's fine. So I'm gonna go ahead and that thing go, and we're gonna go look at the Horsehead. Back menu. Selected slew. We're gonna go to deep space, named, and H. Yep. Most 80s cluster Horsehead Nebula. So again, this is very close, very quick slew. And of course, a PhD decided to choke because it doesn't know what's going on. PhD says, I can't find the star that I was guiding on. So I have to do, oh, I have to do a slightly longer exposure because I don't see any more stars. I have to do, let's see, auto select a star. Oh, there we go. Now I'm getting stars. All right, so let's go ahead and guide. Cool. All right, so I'm gonna cancel this thing. I don't want to do a 4-minute exposure. I'm gonna do let's do a 60-second exposure. Let's take auto gain. Yeah, let's just do auto gain. Oh, you can see jagged little stars going through. So we're going to be focusing on the Horsehead Nebula next and the adjacent Flame Nebula. See what that looks like on here. We have the Horsehead and the Flame. And what you can see on here, there's actually nebulosity all through here. it is not just what you see in this one image. There's more nebulosity here. There's a lot more up here. It's very, very dim. And the Horsehead itself is it's a dark nebula. Think of it as really it's just dust. It is just dust. Here we have a reflection nebula. So nebula that are blue, it's typically just reflected light. It's gas and dust. In this case, this is gas and dust as well. That's blocking out the light from behind. And Hubble's actually been able to use an infrared sensor to cut right through the dust. And you can see there are a bunch of stars all back through here that don't appear because this is blocking it. Hubble will cut right through, and we can see all the stars through here that this gas and dust is blocking. Center. No, wait. Worry about it. No, that's not a lot. No. Oh, there we go. Starlink. Hey, we got a Starlink passing through. Maybe we'll get it. Maybe. We are still exposing. Okay, so the last exposure, we didn't get enough. So we had a Starlink pass through. According to that, a Starlink passed through. Let's see if we can see Starlink in here. And if anyone's wondering, Starlink is the company that Elon Musk started in order to pay for a trip to Mars. It is a constellations of low orbiting satellites to give internet access across the world. I don't see any streak. So either it's too dim, or we just didn't capture it, or we don't have the right time on there, or something. So nothing in here. All right, and 60 seconds is apparently not nearly enough, so we got to go more, and we got to take the gain. And I'm going to take the gain. Where's the gain? Gain. There we go. Turn off auto gain and crank that way up. 4-minute exposure. I think let's do a 2-minute exposure. I don't want to waste that much time. So 2 minute. Oh wow, a lot of it. Hey, we can see something. There's something here in the middle. That is something right here in the middle. I don't know what that is, but that's something. So then we have the flame over here. We can definitely see the flame nebula right there. Here's that dark band right through the middle, and the tongues of flame coming out the side. And this would be the Horsehead. So what's going on right now is we just took a quick exposure with the gain turned way up. And when you do that, well, it's like taking everything way up. So even stuff that should be black is nearly white, or in this case, blue. Another minute. All right. Okay. So, got a question about space or Starlink. So Starlink is right now. I think they're still testing at 45 degrees and higher in latitude. So we don't have anything down here. We're at like 33. Which is really too bad because I would love to be able to get it. Now, there was something I saw this past week. Somebody got a hold of one of the antennas, one of the dishes, and it was non-functional, and they tore it apart trying to figure out how it worked. It is actually a phased array antenna. It is flat, but it's got so much cool tech in there. And what a phased array is, instead of using a dish to send and receive signals, it is flat. Okay, it's a flat sheet. But in that flat sheet are receivers. What is going on? I think my gain is too high. Let's turn this down. Okay. In that flat sheet are receivers and transmitters. The phased array allows you to generate a waveform by and pick a direction you want to send it to by starting it at one end and let's say you're sending a signal. So you start sending the signal with the transmitters on this side, and then you you in sequence, because yeah, best way to put it, in sequence you send it along a path, along a direction on that on your plane, your sheet. What that does is it creates the waveform. So the waveform starts here and goes up and then gets started here, and it travels in this direction. So you can send it in any direction. And you see these on like Aegis cruisers with their radar systems. The radars are these flat panels. They don't have the rotating dishes um, or rotating antennas. It's just this flat panel. But that flat panel they can put a lot of energy into, and direct beams going out, you know, almost over the horizon. All right, 25. So for Starlink, it's this really cool flat panel. And if you go to hackaday.com, there is an article on there that links to the guy who tore it apart. I think he has a YouTube video as well. Sorry, I can't do any better than that. I saw it a couple, I think it was last week. Yeah, I think I saw it last week. All right, a couple more seconds. Let's see what we got. Okay, that's not great, but not horrible. And it's because we've got the gain way up. So let's look at the histogram. And again, if we were in dark sky sight, it would be much, much better to image. So we have bright star right here. We have, you can see a little bit of reflection nebula, but here's the Horsehead. It is upside down. It's really, really noisy. But that would be the Horsehead right there. And it's not nearly as pretty, only because it's a smaller telescope, and of how we're having to do this. We're in the city. We have a lot of light pollution, and this is a very, very uh, dim object to see. I think I know I've seen it through the 24 in a dark sky sight. I don't remember if I've seen it in any other telescope through the eye and through like an eyepiece, and I don't recall seeing it. I know I've never seen it through one of my telescopes. I'm pretty sure you could see it through like a 10-inch or 12-inch in a dark sky sight, um, but it's got to be pretty dark. And through a 4-inch like this, you're just not going to be able to see it. It's just far too dim. And if you're looking at like a department store telescope, good luck. You're never going to see it. Um, a lot of these objects with such a small telescope, they're really hard to see. That's why we're taking long exposures to see some of the stuff, and we're not doing it. We're not just doing it live, so to speak. We have to gather those photons for an extended period of time before we can do it. Oh yeah, we can't see that little reflection nebula right there. Not that guy. Oh, another star coming in off the side. I don't think that's amp glow. Almost there. 5 seconds. 4, 3, 2, 1. Okay, there was a difference. Very, very slight, but there was a difference. Okay, and yeah, not I don't think we're going to get too much better with this. And I say that only because we just have so much light pollution. I think if we were down at Grandview, it would be a little bit better. Here, it's on a cold night. I really didn't feel like dragging everything down there and doing it that way. Okay. Give a minute. What else can we look at? All right. I don't see any. If anyone has any requests, let me know. Let's just go ahead and take a look at Starry Night. While that thing's going, let's look at Starry Night, see what we can see. What is going to be interesting? We have some clusters, diffuse nebula. Oh, got another Starlink over here, and Iridium. Not over here, geosynchronous. Okay, yeah, we're definitely going to be able to pick that thing out. There's a dark nebula. I don't know if we'll be able to cast. See, it's a diffuse nebula. It's also a reflection nebula. It's really hard to pick out. Sirius is big and bright, but I want to find. Yeah, we got a lot of satellites coming through here. Starlink is just all over the place, isn't it? We got 1, 2, 3 Starlinks. I wish we could see them better, but we can't. All right, give another 20 seconds, see if there's any difference in here. And then we're going to switch to the different camera. Most 4, 3, 2, 1. I don't know if you can see that there. Yeah. Any difference? A slight difference. Tiny little difference. All right, I'm going to get PhD. I'm going to stop guiding on PhD. PhD is actually doing pretty well for guiding. I'm pretty happy with it. Okay, so we're going to get just looping it. And what are we going to go look at? I got to go find something. Something different, something better. Not looking at satellites. We have M44. What is M44? Regulus is coming up. Ooh. 44, we got a cluster. Sure, why not? Let's get M44. That is Australis. And yeah, Australis, okay. What is this? Descent craft. Huh. Okay. Neat. Usually I don't have satellites turned on, so not that I'm surprised. It's just, whoa. They're just a lot of satellites. Oh, here we go. Heart and soul. I want to pick out the heart and soul and see just how much we can do. The heart and soul with this thing. Again, I haven't been messing with this at all. So we're looking at IC. This is the heart and soul. And I want, what is this? If I go, what is this number? IC 1805. LND deep sky. Dark nebula. I really just want to see that. IC. Why won't you do it? Why won't you? Let me see. Thank you. My wife just brought me tea. Unless she's really mean and she brought me, like, I don't know, ice water. Is it ice? Okay, here we go. IC 1805. Let's jump to there. IC 1805. Okay, menu. Selected slew. IC deep sky. Deep sky. IC. Okay, we're gonna go 1805. Enter. This is gonna be pointing in weird directions. I'm going to kill the lights. Oh, now it's all dark. Hi. What? Uh-oh. That's not a good sign. What did you do? That was bad. What is going on? I don't know what just happened. Well, let's find out. All right. Just turn off the lights and something happened. Okay. Huh. Okay, that was a bad sound. Oh. No, that's fine. Huh. That's fine. I'm not even sure what happened. That was just a very, very interesting sound. It was a very bad sound. All right, let's find out. Menu. Select and slew. Try it again. Deep sky. IC 1805. That's never a good sound to hear, is it? Okay. Okay. Okay, Flaming Nebula. Let's see what else we got. Okay, we got Rosette and Pleiades. Cluster Pleiades, I think, is. I don't remember where it is. Let's find out. Ouch. Oh, thank you, dear. My wife brought me gloves, which are okay for one hand, but I literally cannot use them on the other one unless I cut the finger off. So, wait. She give me. She gave me two right gloves. Seriously, they're two right gloves. It's exactly the glove I cannot use. Thank you, dear. All right. And okay, let's see what happens here. So we got um okay, so we're gonna be looking at the heart and soul. And I got nothing. Let's see what happens. We got another 20 seconds. 20 seconds, not too bad. So should probably turn out lights just slightly. But yeah. I was just pointing in the right direction, somewhere towards north, but that's where we have more light pollution. So, oh, we're probably going to go for Rosette next. It's on the other side of the sky, but it will be much darker. What do we got? We got a satellite. Satellites? Multiple satellites? They've got multiple satellites. Look at all these streaks. 1, 2, 3. Ah. Because we're pointed not too far off north. Let's see what we're looking at. Yeah. Zoom all the way out. Yeah, so here's north. um, North celestial pole is where? Here's north. North celestial pole somewhere over here. Yeah. So what are we looking at when we take an image through there? Oh, where is it? Where is it? Where is it? Oh, it's always Milky Way. No, 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 no. Yeah. So, yeah. Here's Polaris. So here's this. So what we're seeing actually is polar satellites. We're actually seeing polar orbiting satellites in this view. So we have one right here, 2, 3, 4, 5, maybe 6. Huh. Yeah. So there's one. Geez, we got a lot. Maybe, maybe. At least I think those are satellite. Well, maybe. Well, here's a long one. There's a long streak for a satellite. Okay, so we just had a new image come in, and that streak is gone. All right, let's see if we can find any more polar satellites. Zoom out to 50. Don't see any right now. They may have not been satellites. May have been from moving the camera or something. I don't see anything right now. No, we did have that one streak before, so okay, that must have been a satellite. The rest probably were just stars. Okay. Well, I was wrong. Not the first time. Won't be the last time. But I think we have way too much light pollution over here to see the heart and soul. Period. It's just not even there. So the rosette, we can try the rosette. I'm just kind of worried that that's also going to be too much light pollution, but I have zero problem trying. We can do well. Uranus is going to be hard to get. Neptune should be much easier. Where's Neptune? Oh, maybe not. Maybe. Oh man. Here's Pleiades. All right. So where is Neptune? Don't tell me Neptune is below the horizon. It could be. All right, let's see. Where's Neptune? We missed Neptune. All right, we can do Uranus. I want to see Uranus. Really got to be careful with that one, huh? All right, select slew. We're going to go solar system, Neptune, Uranus. I could just be careful with that, or I could just go all out and say, let's look at Uranus now. And that is why we say Uranus too. Okay. All right. Next, here we go. What do we got? What do we have? So I think for Uranus, we should be able to pick up a much, much faster. I think a 30-second exposure should be plenty, so we can see just where it is. Ooh. Satellite. That's a fast one. Okay. So we're only going to do 30-second exposure. Let's see, where is Uranus? It should be... Oh, there it is. Uranus is really obvious. That's really obvious. Okay. So let's go 100%. Yeah. No, maybe not. I'm going by color. So that right there. Go 100%. Just by color, that looks like it's it. It's also close to the center. Um, yeah. Being close to the center, this is where it should be. I'm kind of doubting it's anything else. So what I can do is always turn down the gain. Yeah. Oh yeah, that's it. And we look at the color for Uranus. It's always going to be this this pale blue, blue green. Yeah, it really stands out. All right. So we know where Uranus is right here. I'm going to switch to the other camera because I want to pull a spectrum out of this thing. And I want to see, I just want to see what we can do with this. Let's see. Give me 16. Close. We're looking at a, just do a 30-second exposure. Over here, grab that, and that will start guiding on that. See how that works. Oh. And my wife just texted me, why aren't I wearing my gloves? I will let her know you gave me 2 right gloves, and I have to use my right hand. Oh, and where are the hand warmers? The hand warmers are in the car. I left them in the car from last time. So, okay, what do we got? Oh, guiding. Oh, guiding's off. Stop, stop, stop. I have to, the guiding, I have to modify, clear my calibration because now I'm pointed at a different part of the sky, and then I have to let it recalibrate. Let that thing go. That's why the stars are streaked. That is okay. Back down. Now we gotta figure out which one is Uranus again. Remember, we're taking spectrum shots of all these. So we're actually getting spectrums of all these stars. So that's pretty cool. Go ahead and do that. And let it start guiding. Okay. I have to keep looking over to see what the guiding is doing. Where did it? The planet Uranus? Yeah, it is. Huh, okay. it's still not guiding it. It's still doing the calibration, so we have to give it some time. Um, that's pretty cool. Okay, so we're letting it do its thing, and I think I need a little bit more light on me, so I'm not totally completely dark. Any other questions? I don't see any, but here we go. A little bit more light on me. Okay. And now we're guiding. Okay, so next exposure should be once this thing clears out. Okay, so we got one more exposure. And let's see, which one is Uranus? Man, I forget. Ah, which one was Uranus? Let's look at this. It's over here near Mars. Are we getting both Mars and Uranus in the view? Maybe. Mars might be the big bright one. Okay. What are we looking at? See, if it was in color, it'd be easy, but we don't want it in color. No, no. So what are we looking at? Two bright stars. And Uranus over here. Let's center this out. Okay. Two big bright ones. Two big bright ones. Okay. Then 1, 2, 3. So we got this third one. So we're looking at 1, 2, 3. So Uranus will be right here. 1, 2, 3. Uranus is right there, isn't it? Or right there. Let's see. If it was in color, we'd know right away. 1, 2, 3. Okay, so we're making a triangle with those. Okay, so we have a star here, and a star here, and Uranus is going to be the one right over here. Okay, so if we're looking at here, that should be it right there. But this is the spectrum coming off of Uranus. That looks like it's it, isn't it? Or are we looking at Mars? I don't think we're looking at Mars. This looks like it's at 1, 2, 3, and then that one should be Uranus right there. All right, so 30-second exposure. I don't think this is enough. I think we need to go, and it's fairly close to the center. I'm going to do 60-second exposure because what I want to do is I'm going to pick off, let's see if we can find methane. Let's see what gases we can pick off in the atmosphere of Uranus. All right, give it 60 seconds. I should start the capture. Single frame Uranus. Uranus and start capturing. I could probably do more. I will let Pi know. Okay. And car. Back pocket. Okay. All right. Where? Wow. Okay. So that's pretty cool. All right. So we have that. Well, I guess did I capture it? I hope I captured it. Let's find out. Sharp cap here. Rigel. Uranus. All right. I got something. All right. Let's see if we can load it up in here. Again, I have no idea how this is going to work. About to find out. Rigel. We're going to go to Uranus. Grab that. Zip its file. Oh, man. All right. Uh, uh, Hmm. Okay, what are we looking at? What are we looking at? We're looking at one, two some bright stars over here, and one over here. So two bright ones at the top. Ah, right again. Okay. Um, two bright ones at the top. That one off to the side. This one I think is Uranus right there. So here's what I need. This, and let's get it way down. And honestly, I could probably go with longer exposure to get more data out of it. We're not getting much. I think that's a methane line, though. I think that's a methane line. I'm not 100% positive, but we got something. No, no, that's not it. Jeez, I think I have to go in there and actually do some more processing on it. Really just grab just that spectrum and nothing else because there's not a whole lot of data in there. There's something, but yeah, it needs much longer exposure. Like yeah, maybe I should do instead of a TIFF, sorry, instead of a FITS file, do a TIFF, and then probably blow that up even more. Pull this out. Yeah, see, it's getting interrupted by. No, maybe that's the line that I'm looking for. That's what I want. I just don't think that I have enough data in there. It's also towards the north, so there's a lot of light pollution coming in. Yeah, I don't think I'm gonna be able to pull off too much. It's just not ideal right now. That's too bad though. I was really hoping to pull out some more data. I think if I put this, if I put this onto um, the CPC 1100, the 11-inch scope, I think I can actually pull out some decent data. I think that might actually work better. But I didn't bring it out today. It's a very, very heavy telescope, and it's just it's big and heavy. I cannot set it up myself, so my wife has to help me, and I just didn't feel like dragging it out today. Um, Maybe, well, Uranus is going down. May have to wait until next year. Uh, Actually, the summer, yeah, may have to wait until the summer. Um, until Uranus is back up in the sky because it's going down low. So unless I do it from Grand View next time, I think it might not be doable. Where did I put the keys? Um, I don't remember where I put the car keys. My wife is wanting to give me the handlevers. Okay. Any other questions? Let's see. Nope. Hmm. Yeah, I think a longer exposure, a 2-minute exposure should be better for this. But there we go. Yep, it's quick. Let's double check. I just want to make sure that is what we're looking at. So one, two. Oh, well, that was fast. Yep, one, two, three. So we're getting this area here. Yeah, yeah, this is it right there. So that would be Uranus. One, two. Okay, yeah. Especially if we're looking at this one. Yeah, one, two, three. So here we go. This is Uranus. No, I can't zoom in on this. It's not quite centered. That's okay. All right, we're not going to worry about it. Yeah. All right. So what's next? Rosette. Let's look at Rosette. Let's find where the Rosette is. To be down towards the south. Down towards the south. Oh no, Pleiades. I'll do Pleiades. That's up close. So this is M45. That's easy enough. Back menu. Ooh. Select and slew. Sky objects, Bezier, M045, enter. Well, I can't find the key, so she told me to be cold. Oh, and I have to stop the guiding. Where is it? Go. Okay. Guiding again. Now we should be pointed at the Pleiades. Gonna go switch to a different camera. Go to. I want to see what we're looking at. Where are we looking at? And also, where's it pointed? Pointed up. That can't be pointed to Pleiades. How's that pointed to Pleiades? Oh yeah, it is. Okay, never mind. It is. Let's go. Sent. Much longer exposure. I wish I had like little shortcuts for this, but I don't. Okay, 8 seconds. Thank you. You look cold. Yeah, this isn't working. All right, I'm gonna do this. I think this camera's having issues. Actually, I know this camera's having issues, so I'm going to check something else. Let's see. Do this. Does not like that. So, will it let me take an 8-second exposure? I want to get the wide angle. It's not going to work. All right. I'm going to try one thing. The camera's actually right here. I don't know how well you can see that. Can you see that pretty well? Here. Not terribly. All right. So I will flip this thing around. And plug it. I don't know if I can unplug it. So I actually have this on a nifty little deal here. 1, 2, 3, 4, 5. Back in. Down again. If it'll do its thing again. It's just told me that it does not like it. All right, rescan for cameras. Scan there, sees it now. What I'm trying to do is show just that part of the sky with the Pleiades in it and see how well we can see this. 50 seconds, or 50 milliseconds. Try 8-second exposure. Will it take it? I hope it will. There we go. The Pleiades right there. Could be. Let's stretch the histogram. We're looking at something. I forgot I had the lights on. Sorry about that. So what are we looking at? Where is this pointed? I think something is. I don't know if we're looking at the right stuff anymore. I wonder if something just happened. I don't see the Pleiades in this view. Pleiades should be over here. There's Orion. Okay. You know what? I can't see anything. My eyes are no longer dark adjusted. Oops. I don't know what I'm looking at. All right, let's go to here. So we're looking at the west. Pleiades should be overhead. What are we looking at? Where is it? Where is it? Where is it? I need labels at historic nebula. No, I don't want that nebula. Usually I can see deep space, and I want, you know, this is, I like this version, but then I hate this version. I like this version because it has a lot of really neat stuff in it, but I also hate this version because it makes it a pain in the butt trying to find some stuff. So Pleiades should be, there's Pleiades, M45 right there. So I should be looking nearly overhead towards the southwest, west. I don't think I'm looking at the right place. I'm actually pretty sure I'm not looking at the right place. I think something just happened when it started grinding. Now I'm going to have to re-center. Okay, so let's do this. Where's the Pleiades going to be? I can't see anything, so I have to step back. It's just really hard to see with my eyes. So that's fun. Okay, so here's what I'm going to do. I'm going to swing it past on something I can easily see. I can easily see Sirius. We can get it back on Sirius. So I'm going to do select slew. We're going to go to stars, name stars. There's Rigel. I can do Rigel as well. It doesn't matter. All right, let's go to Rigel. Sure doesn't bump the chair again. Kill the guiding. I think next time I need to make sure I don't push this or bring it too close. Nope. This is not good. That's not good at all. Not good at all. No. No, I've got to go to Sirius instead. And the reason is this is tracking past Meridian, and I do not want to do that. Sirius, more Sirius. There it goes. Enter. Nope. Nope, 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 nope. This is bad. Ah, nuts. This is bad. All right, we'll do it this way. It's way past Meridian. Okay, yeah. I have to resync on Sirius in a complete different way. Apparently, it's not even pointed the right direction. So something happened. I gotta fix it now. Don't worry, this won't take very long. Kind of know what I'm doing sometimes. I think I do. Yep. Here we go. Okay. Now we're pointed pretty close to Sirius. Make sure I don't yank out any cables. That's always fun. Now I'm going to need to take a break. Okay, that's Sirius right there. Okay, that's good. So I'm going to see if we can center this out a little bit better. How about 1 second? Okay. see. Where does it go? All right, let's do guide scope. Oops, nope. What does a guide scope see? Guide scope sees nothing. Oh, there it goes. Well, something. Sees something. Pretty sure that's not serious, though. Nope, definitely not serious. So, okay, wrong direction. Go up. There it goes. Ah, there we go. Okay. And there we go. Now I can see it in the guide scope. That's a plus. Okay. If I can see in the guide scope, that's good. Okay, now I can go. And let's grab it this way. So there's Sirius right there. Okay, cool. Next. Let's see, where does it move to? It's up. Up, wrong direction. Almost. Almost. Oh, I'm trying to center it out here. That's what's going on. Trying to center it. Or close to center. Because I want to do now. Up, down, no, that direction. Tiny bit. There we go. That's pretty close. Now I can say menu, sync to target. No. No, 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 no. Menu. Alignment. 1-star alignment. Sirius. Well, that's bad. 1-star alignment. Sirius. Okay, let's see what happens if I get this right, because I'm going to have to move it in the right direction. This looks bad. Nope. This is going to be bad. All right, how about this? When in doubt, reboot. Okay, so my problem is whenever that grinding noise happens, it was bad, and it knocked out my alignment. So we weren't even looking at Uranus. Definitely we're looking at M45. We're looking at something totally different. So what we got to do right now is I'm parking the telescope. I'm going to see if it puts it in the right position. Oh, it is not the right position. It is totally not the right position. It is not parked. So I have to reset it and then turn it back on, or turn it off, turn it back on, and then go from there because it is not parked at all. Ugh. All right, let's see what happens. Yeesh, not good. Something seriously went wrong. Okay, so the way I fix it is hold on and hope for the best. Okay. There. I'm actually coming in and redoing the loosening up the clutches. Not balanced terribly well. No, it's not one thing, it's another, right? Turn it off. So I've rebooted it, and now I will attempt to do another. Oh, oh come on, really? Okay. Now, try another alignment. Let's see. Yeah, so I haven't done this before. While um, okay, and I will try one more. So we'll do alignment, 1 star, Sirius. Hopefully this will happen. This will work again. So the telescope itself, or the mount didn't move. The mount was actually okay. It's just getting getting it pointed the right direction. Sirius is not yet past the meridian. Good, good, good. All right, it's actually pretty close to where it should be. Okay, so we're getting there. We're getting there. Okay. So it's pointed pretty close to Sirius. It's not bad. Center it. Okay. Now, pretty close in the field of view. The question is, okay, yeah, it's pretty close. Now I have to center it out. Let's see. Okay. It's there. And down a little bit. That's good enough. Enter. Okay. Okay. We're fine. Okay. I think we're going to be okay. I really ought to do a 2 star alignment, but I think we're going to be okay for one. We'll just leave it as it is right now. All right, what's next? We're going to go back to M45. Let's see how well this will work. Selecting slew, deep sky. We're going to go Messier, M45, enter. I really hope this is going to work. It is 9:45. And yes, I do go to work tomorrow morning. Looks like it's going in the right direction. Yep. Better than before, at least. Okay. All right. Oh, yeah. Okay, we're good. So we're going to go here. And yeah, let's get it much, much longer. Okay. We got that exposure there. That. Okay, so the guide scope's picking it up just fine. Gonna make a longer exposure onto here. Let's do a 15-second exposure. All right, let's see what a 15-second exposure does on this thing. I should probably be shooting raw, but that's okay. What do we got? Well, that's part of them. So let's do longer exposure. Let's do 60-second exposure. Okay, so 60 seconds. Actually, while that thing is going, I'm gonna show you PhD. What PhD is showing. So this is the view through the guide scope. So we can see 1, 2, 3, 4, 5, 6, 7, and then a couple of the smaller stars through here. This is a 2-second exposure. So what I'll do is clear that out. And I have to make sure that it's clear the calibration data. And I'm not going to do anything quite yet. I'm going to let it take the exposure. 15 more seconds. Let's see what it's going to look like after a minute. Let's see. Gain is auto. That's fine. We'll just see what it looks like. Okay, we're picking up quite a bit. We're not picking up any nebulosity yet. It is fairly faint. I think we need more than just a 30-second exposure or 1-minute exposure to get that. Let's see, where's my mouse? Let's see what this looks like. Yep, we're picking it up, but I don't see any nebulosity yet. I think we need a much longer exposure. I think we really need really dark skies, but we can see what we can do. I like a 60-second exposure. I think we got to do a 3-minute exposure. And let's see what happens. But I should probably we'll let it do a 3-minute exposure, unguided. Just let the mount handle it and see if it can handle 30 or 3 minutes. In the meantime, while this thing is going, I really, really, really have to go inside for a minute. So I will be right back. Please don't leave. Just watch it change very, very slowly. I wish I had some music, and but I don't right now. And John says I really ought to wrap it up at 10 p.m. Nah, we'll keep going. Keep going until my wife yells at me, which might be in a couple more seconds. Sorry about that, everyone. Okay, I'm back. Um, my wife had a bit of a fright because she was watching me and just watching and listening, and all of a sudden, uh, I'm in the bedroom and she's still watching me on the live stream. There's about a 30 to 40-second delay, so that's why. All right, so we have one image that came in. We got another one in just another minute. Let's see what happens when I bump up the histogram. Okay, so there's a little bit of nebulosity right through here. I think with a darker sky and longer exposures, thermal. That's why. Okay, get the thermal control on. Get a chip cool down more. Ooh, so it's pretty cold, but it could be a whole lot colder, so we can get more data out of it. I think if I have, I think if we have the gain turned up more, we should be able to get a better image. Let's see. No, too much gain. We have a little bit of streaking. And I can see some nebulosity. Let's look at the histogram again. Kind of. I see a little bit at least. Yeah. Okay, so I do have some amp glow coming in from this side. Using a dark frame, I can get rid of that. It's not a huge deal. It's actually not terribly bad. Um, but this, yeah, there's a little bit of nebulosity we can kind of see. If you kind of, yeah, if you hold your face just right, you can kind of see it all through here that doesn't appear out over here. And it's not like it's only in the center, it's kind of splotchy. So, and then over here, we do see some of that reflection nebula coming off of this star. That little line right there, that little bright line with the back, that is actually what it looks like. There's that little reflection nebula. So it's stuff that we can see. It's just not ideal in the city, unfortunately. So I kind of wanted to do some uh, narrowband imaging tonight, but it's 10 o'clock. It'll take me a little while to get it set up and do focusing and all that. I don't really want to get into that right now. What I want to try to do, though, is now that we have this, I don't think. Let's see if we can find Uranus again. I kind of want to find Uranus. I kind of want to get the spectrum, but I just fear that with this telescope, because it's so small, because both these are kind of small, I really need a much better exposure. We had good luck seeing Uranus. Oh, when was it? Last time? Yeah, I think it was the last star party we did for Jupiter and Jupiter and Saturn conjunction. So this was December 20th. Yes, last star party that we did. We had the CPC-11 down in Grandview, and we were actually able to use it to look at Uranus and at Neptune. And for Uranus and Neptune, we were able to see some of the moons. So I think we could see Triton with Neptune, and we could see, I think, like 4 or 5 of the moons of Uranus. So that was actually pretty cool. What else are we looking at? All right. Oh, Steve says he was out with his telescope and he missed the party. That's okay. That's why this is recorded on YouTube. You can always watch it later. Okay. So we got 8 more seconds and then we'll call it quits for Pleiades. I'm just not getting that much luck out of it. I think we're still too close to the city. And yeah, we're still too close to the city. We can see a little bit of detail. You can see this tiny little eyelash almost right there. And we're getting some streaking with the stars, so that's not going to help. And I'm not guiding it right now. Let's see what else we can look at. So here is, so we can go straight down to Uranus. Then we have another Starlink coming over. I need to turn off these satellites. They're just kind of annoying. Turn off the satellites. What I want to see, I wish this thing was better. All sorts of nebula through here, but this is stuff that we really want to see. in dark skies, not over here. Hey, we have M31. You know what? This will be it might be kind of hard, but let's see if we can get M31. M03. So this is the Andromeda Galaxy. 31. Enter. This is Andromeda. And see what it looks like out here. This is the guide scope image. This is 2 cent exposure, and looks like it's going in the right direction. And PhD also does some magic with this, so I'm guessing that's probably. No, I don't know. I don't know where it is, but let's try guiding on that thing. Oh, it's gonna do its thing. All right, that's fine. So we're gonna come in here, and I'm gonna change the exposure from 100 from 3 minutes. Let's just give me a 30-second exposure. It'll be streaked way out. Or this is data mostly from the Pleiades from M45. I want a quick little exposure. I just want to see. This is basically for framing. I just want to see where is Andromeda. Oh yeah, she gave me tea. I totally forgot. Let's see, where is it? There it is. Okay. Oh, it's still doing its thing. It's still guiding. Nudge south. I really like PhD. This makes guiding so much easier. Um, I can't tell you how frustrated I was in the past trying to get it to work with my equipment, and it just now everything's just rock solid. Oh, still not quite rock solid. I need another exposure. Guessing this is probably it down here, so I have to get it up in the frame. Thank you, dear. It's very, very hot tea to the point where I can't drink it yet. It's steaming up quite nicely. I can't really turn the lights on because it'll be shining into the camera. That's never a good sign. Never a good thing. So I'm going to take the tea, put it off to the side temporarily. We're not looking at the right location. I'm pretty sure this is it down here. So I'm going to have to do, let's see. I'm going to have to stop the guiding because it'll lose the star. Okay. Seconds. I'm going to have to kill that to be a lot less. Okay, wrong direction. 15 seconds. Yeah, I don't think it's aligned just where it should be, but that's okay. We'll fix it. I think I'm in the right area, but we'll find out. I mean, I know I'm in the right area. Just a matter of hunting it down. Okay, there's those. Oh. Recenter it. No, where is it? Do another 30 seconds because looking for it down below and I don't see it. Nope. Well, isn't this fun? I want to see where it is in the sky. So if I don't find it here, I'm switching to the other camera. Anything? And what we should be looking at, it's a matter of finding it. Where can it be? This is not it. Nope. No, I should be able to see it right in the field of view. Let me switch to a different camera. Let's see if this one's going to work. No idea. I'm gonna fail again. This is my planetary camera, and fine. You're not that concerned about it. Okay. So here's what we're looking at. Here are my trees. And there is the W of Cassiopeia. Is that it right there? There's Andromeda. Is that right there? That's probably closer to where it is right there. So 8 seconds. 15 seconds. I want to see just how much I can pull out. I'm just curious, just how much data is in there. Yeah, that's not too bad. Not too bad. So that should be right there. Yeah, that's it. That's Andromeda Galaxy right there. We can see it. I'm going to zoom in. Yeah, that's it right there. So a TV camera attached to a cheap little planetary scope, and we're able to see that much. We're able to see a galaxy 2.2 million light years away. It's not bad. It's not bad at all. All right, let's switch to this. Close. I will go to RAW 16. I swear I've just got to get rid of that. I don't know where that is. I don't remember. There's there's like a whole ASCOM thing on here, and I can't remember where it is. And it's a focuser. Sharp cap settings. How about this? Hardware. There it is. I need just none. Just none. Let me go somewhere. All right. Good. And definitely need longer exposure. So it's somewhere in here. I don't think it's the right location. I don't think I'm looking at it. Or let's get it chilled down again. Let's see. So yeah, that was a star at the bottom. That was actually, I think that was actually Andromeda. That's why I'm trying to bring it back. Recentering. Gain. And I don't see it. Nope. There we go. That's it right there. Question is, which direction do I move it in? How about this? We're gonna build a 15-second exposure, and yeah, 15-second exposure. Take the gain, and just ramp the gain way up, because I want to see exactly where it is, and then start moving it. Well, that was dumb. How about this? Okay. Here we go. So I'm gonna go. let's see what happens. Trying to move it up. Hope I'm moving in the right direction now. No. Where did I move it to? I have no idea where I moved it to. Not a clue. And it's times like this, it'd be really nice to have a, oh, what do you call it? I forget. Plate solver. And I have Nina on here, and I have the astrophotography tool, but I have not had a chance to play with them at all. Where did it go? Try this again. Where could it possibly be? So I recentered it. I'm going to try to grab Andromeda. At least get something. There it goes. Okay. So that's what we were looking at earlier, that bright spot. So the question is, which direction do I need to push this into? I will go, say with this. Yeah. I moved it. So we're looking at Andromeda. So this is one of the satellite galaxies of. This is one of the satellite galaxies. And this is the Andromeda core. And this is another satellite galaxy. Let's see which direction I moved. I hit this button. Okay. Wrong button. Okay. So let's see if I get it right button now. I don't think so. Pretty sure I hit the wrong button again. Yep. Nope. Okay, so that's the right button to move in the right direction. Now I need to go. Okay, so now I'm looking at the position of this. I hit the down button. Let's see if this moves it the down direction or the up direction. Okay, that's good. 6. Let's get it more centered. I really want to just get it more centered at this point. So, I check something on here. Where is it? Yep, okay. All right. That's better. Okay, now we have Andromeda. Let's see what happens. I'm going to see. It's a lot cooler now. Okay, so we're going to play with a couple things. One, I'm going to bump this up to, let's go with a 2-minute exposure. I'm going to take that gain. I'm going to drop that gain way down. We don't need to be that high. So 2-minute exposure, let's see what happens. It is pointed to the northwest right now, so we have to deal with some light pollution. Again, I have a light pollution filter on here, but it's never that good for galaxies. Light pollution filters are really meant for nebula. So they block out everything that's not hydrogen alpha and sulfur and hydrogen beta, oxygen, things like that. There's some wideband filters as well, and what they do is they block stuff like mercury vapor light. So the street lights that are the yellowish orange color, that's mercury vapor. There are also some sodium vapor ones. Those are typically the ones that are like on highways, the big bright ones. So these filters will block out that light, which is fine. But now with LEDs, the issue that we have is, well, with mercury vapor lights and with sodium vapor lights, the light is fairly. It's not really narrowband, but it's a certain bandwidth of light that gets hit. or that's emitted. And you can block those with the filters. With everyone going to LEDs, that's different. LEDs are a more broadband uh, light source. So it's a lot of frequencies, not just one or two. And then when you have RGB LEDs, now you have all sorts of stuff. So like the lights I have behind me, these are RGB LEDs. Those are really hard to block. So what we're seeing is a brightening of the night sky, even as we're using less electricity to light up the night. The LEDs are just so much more efficient that our electrical usage went down a little bit, but there's so much more light because one, it's just gotten a lot cheaper um, to do, so it's easier to light stuff up. All right, what do we got? We've got that. That is the core of Andromeda. Not a whole lot of gain. Let's see what happens when we mess with the histogram. Now we got something. I think we could use more gain and a much longer exposure, but 2 minutes, punch up that gain. Yeah, that should be enough. I'm not picky right now. What do we have here? So we have Andromeda, we have the spiral arms through here, we have a dust band that's really, really visible here. It's not too bad at all. And again, if we were going to be taking images of the galaxy, I would be typically out at a dark sky site doing it instead of doing it from my backyard. There's just too much light pollution here. This is, let's see, we have, what two galaxies do we have there? It is M110 and M31, M32, and M110. So here's M110. This is M110 out here in the corner, and this is M32 right here. So these are elliptical galaxies which are orbiting the spiral of Andromeda. They're smaller, we call them dwarf ellipticals. And you can see the galaxy is all through here. This is fairly big. And the moon is, how big was the moon on here? It was taking up a good chunk, but the galaxy itself is much, much bigger. So this is like, I think it's like 4 or 5 full moons across. And so what we're seeing here, our image is this. We're not picking out a huge amount. And also, it's upside down. This is upside down compared to the image we have. This is the very edge, right over here. Okay, turn that way too much. Let's see what happens if we do this. There we go. So you can see the entire field here is being taken up by the galaxy. And this is off to the side, and we have this over here. So what we're looking at, our image is extending out over here, to here, here, to there. This is roughly the image square here. So we're missing all of this over here, including this neat little NGC object. There's a cluster right through there. It's hard to see because that thing keeps popping up, but this is a cluster with its own NGC number. It's new general catalog. We can see the core, and we can see these. So if I move it down, we'll be able to pick up that NGC over here, a cluster of stars, star-forming region in another galaxy. But as it is, with a 2-minute exposure, I guess I can cut the gain down a little bit so it's not as grainy. That's really all I can do. This is a wide field telescope, but it's a smaller sensor. So if I had a bigger sensor, I could, get more of the galaxy. But this is not bad for what it is. I would just be doing this in a darker site and much, much longer exposures. I'd be doing probably a 5-minute exposure instead of what this is. So let's switch to a different camera. And just for kicks and grins, I want to see what I got over here. Okay, it's going to be a quick exposure. 50 milliseconds. I want to take a, let's go with the 15-second exposure. Oh. Hey, at least it's not throwing out that other error, huh? "15 seconds. 3, 2." What do we got? What do we got? There we go. Okay. I don't know what we're looking at. I don't know how close we are to whatever. I wish I could do multiple sessions of sharp cap, but I can't. So um, it's hard to do. And then when I tried to do nebulosity, it was not able to pick up one of the cameras, either of the cameras. I'm gonna try it once more. If I can get it. But that's kind of annoying. And the QHY, it's not picking it up either. I think I just need to update on this thing. Yeah, it's not letting me connect to here. Maybe there's an update for nebulosity. Yes, there is. Okay. Yeah. All right, so I need to go hit. Of course it would. Of course it would. So the newer versions of newer versions of nebulosity. I'm at 4.1, and we're up at 4.4. So I need to go ahead and download latest version of nebulosity for next time, because this ain't gonna work. But that's okay. I'm not gonna worry about it right now. I guess I should have thought of that before, but I haven't used it in a while. So if I had been testing with it more yesterday, then that would have been something else. Quick 60 seconds. I think let's just go to Uranus. I just now I'm curious. Menu select slew. Not Mercury, not Jupiter, not Saturn. Uranus. I'm just curious about this. Cancel. Close that. Let's see if I burn myself on the thing of tea. It's hot, but it's not terribly hot. Okay. What do we got? 2 seconds. 3, 1. Okay. Probably Uranus right there. It's kind of hard to tell if it's black and white. Maybe one of the brighter things here. Yeah, I don't have my alignment perfect. Close, but it's not perfect. So I'll have to play with it. Next time, not tonight. But all in all, this isn't too bad. We're able to look at one spectrum. Well, might as well. How about this? Let's just go look at Betelgeuse. Might as well. So let's do this. It is 10:22. I got to go to work tomorrow. I also have to clean this stuff up because some of the stuff I actually have to use for work tomorrow. Um, so let's do this. Let's look at. Let's go back to Orion. Let's look at Betelgeuse and let's just do some spectrums on there. So go menu and select slew. We're going to go to stars, named stars. There we go. Oh, so many all. so many all. Bellatrix, Beta Hydra. I have to check where it is exactly. Switch to a different camera. I hope this works. Please work. Please work. 8 seconds. Anything? Gain. Auto. Let's just do auto gain. There we go. Now pointed back at Orion. On its side. Just because of the way the camera's kind of laid out. So if you're actually looking at Orion in the sky, this is up, this is down. But the telescope doesn't see it that way. The telescope is rotated differently. So it's what we got. We'll be looking at Betelgeuse right there. It's that bright red star. And I'm gonna, just for kicks and grins, let's just do I want to do a 15-second exposure on this. I want to see what it looks like. I think this view is kind of cool. Let me know what you think in the chat or in the comments. Oh yeah, and like and subscribe and all that. So if you subscribe, you do get the notifications on when I put up the new videos or when I have new videos scheduled. How's that? So we see a lot of stars through here, and there is a reason why we see a lot of stars. We're looking into the Orion arm of the Milky Way. So the winter Milky Way passes through Orion. And so you see all these stars. Now, we're not looking towards the center of the galaxy like we are with Sagittarius during the summer. So we don't see nearly as many stars, but we're still looking into the Milky Way and not out of the Milky Way. Like, as in, we're looking through the galactic plane, not out of the galactic plane. So we can see all sorts of stuff in here. But yeah, a lot of stars. Orion Nebula, you can clearly see the color in the Orion Nebula just from this. So think about this. This is a cheap, relatively cheap planetary camera. It is 1280 by 960, and I just attached a very cheap C-mount TV camera to it and play with the focus until I got it pretty close to where I wanted it. You can see there's significant coma in the corners. The stars are not round. This is not a great lens, but it's good enough. It's good enough to see what's going on. And that's really the only thing I kind of care about with this right now, right here, is just to show this is what we're looking at. This is the region of the sky. This is the overall thing. Because a lot of times when you're doing stuff like astrophotography, you're taking photos of really small targets. Even if it's the moon, it's just the moon. It doesn't really tell you where the moon is in the sky. So right now, this is almost due south. Let's see. Yep. Almost due south. Just a little bit past towards the west. And again, this is up and down. So when you're looking right now, Orion looks like he's standing up. We have shoulders of Orion. We have 3 belt stars. And we have the sword, and down here, his feet. And there's more with like, the bow over here, things like that. But in general, this is what we got. I'm looking at the guide scope. I don't think this is really aimed close to Betelgeuse, so I will get it closer and I'll resync it and see if it does better. It's like in the worst position for me to actually get in here and see what's going on. This thing's so low. Just not comfortable. Boy. see it. All right, try this way. Feeling on the ground. So I have to get the light. This is definitely. On the ground. There it is. Close, but too far. Close. Yeah, I was actually crawling on the ground. Not terribly comfortable, but it's much closer to the center. I see in the guide scope, it's big and bright. It says closer to the center of where it should be. I'm going to switch to a different camera. I like this view. I really like that view. It shows more of the sky than just a zoomed in view from the telescope. I'm gonna go 25% to get more, and there it is. So I'm gonna go now to much longer exposure. Give me 4 seconds. All right, 4-second exposure, that's fine. So let's find the other camera. I don't know how close I am to that one, to being centered. It is getting cold. 10:30, yeah. Oof, okay. Any other comments, questions? See anything? All right, so that's that over there. That could be. Let's see. All right, go slow. 50. Probably needs to be a little faster than that. How about 1 second? Yep, I'm guessing that would be Betelgeuse. Let's see. See if I can get it. There we go. Oh wow. Okay. Yep, that would be it. So, so I'm gonna slow this way down. That is that's a nice spectrum right there too. And as I could move that, you could kind of see those lines. That's pretty cool. All right, so now I can go in this direction. I need to get. Yep. Okay, so we got something. Wow, just look at that. That's pretty cool. That's pretty cool. Okay, so I'm gonna do a quick capture of that Uranus. I'm gonna call this Betelgeuse G spectrum. Okay. Yeah. So let's do that. Let's pick this out. Definitely not. Fingers are so cold. Okay, here we go. I'm pretty sure. Uh, not pretty sure I need to be rotated the opposite direction. Um, 314.5. What's the opposite of 314.5? Six. 40. Six. 5.5, that looks better. Probably one more. Okay. More. Okay, I have no idea where. No, that would be it, but looks like we're too close to the edge. It does not like it being that far off the edge. We got something. We got something. I don't know where the star is, but we got something. Let's go back here. So we should be getting a lot of data right there, but just not getting it. I wonder. Oh, because mono 8. Let's switch to mono 16. Lots more data from this thing. And I don't know, 1 second? Maybe we need more. Let's do 2 seconds. 2-second exposure, see what happens. It's more. It's something. I don't know exactly what, but it's something. Let's try another. No idea what's going to happen. Okay, it's just more data. So, what type of a star is Betelgeuse? Let's find out. We have to do some calibration on here. Actually, we always have to do calibration. But I want to figure something out. Remember, I've not done this before. Pretty cool. I just haven't done it before. So usually you're supposed to use a type A star like Vega to do your initial calibration, but Vega's down. So just all right. So variable star. Yep. It has not exploded yet, or if it has, we don't know. Okay. Oh, another satellite coming through there. That's fine. Class M, red supergiant. Okay. All right. So it should be class M. And we can kind of see that where previously we had a lot of stuff in the blue. On here, it's shifted way to the red. So there's probably a lot more over here. Okay, how did we do this before? Show elements, elements, elements. I want to see type B, type M. Okay. Nope. Not a wolf brain it, dang it. That is pretty cool. Type M. Okay. The Balmer series. No, that's not what I want. I want type M. Okay, so what are we looking at? Dang. Okay, so Betelgeuse is off the scale over here, which is really too bad because that gives us our 0 point. Instead, we got to figure out. I got to do the calibration. Let's see. Use 1 point alignment. Okay. So what if I do? Yeah, I don't have a 0. Pixel number 1 over here. It's like, is this it? That's not exactly it. So I don't know. I'd have to begin over here. And then over here. This is not so easy. So if I do a type M, there we go. Now if I can play with this, I can come over and I can see, oh, here we go. No. No. Yeah, this is it's gonna be off. I can't calibrate without having a oops, yeah. I cannot calibrate without actually having um someplace to calibrate to. See, this is not gonna work. Yeah, this isn't gonna work, which is really too bad. Um Yeah. Nuts. Okay, because what I'm trying to do is calibrate these lines against these dips. And I need the star in the field of view, and I don't have the star in the field of view. So the only thing I can think to do is move this a little bit more. Let's see if I get in the right direction. Yep. Wait. Oh, man. I did it wrong. No wonder it's not working. No wonder it's not working. We did it wrong. It's the same on both directions. Okay. Now we should do it. That's fine. We're figuring it out. Okay. So Miguel here, new, just showed up. So Miguel, what we're doing is we're taking a spectrum of the star Betelgeuse in Orion, and we're trying to figure out some stuff from it. And this is the first time I'm doing this, so it is experimental for everybody. Okay, so what do we have? We got something. Um, let's see a 1 second exposure, see what that does. If that's going to be better or worse. Can't tell. I can't tell if it's going to be better, if it's going to be worse. Not a clue. One thing I can do is switch it to a TIFF and maybe even a FITS. I believe is it. Yeah, well, it can do FITS, so let's just do FITS. I'll do a capture, a single image, start, back here to RSpec, and we're going to load it up. Okay. See we go. Now we got it. Now we got it. Okay. Time to rotate. Rotate. It was what, 314.5? Yeah. Nope, too much. Most. 6. 314.5. Good. Okay. Now we can come up here. All right. Okay, now we have to. Ooh. Now we actually have a spectrum. Okay. Okay, let's open this up a little bit more. And we need a 0 point. Okay. All right. So it's kind of hard to tell where the 0 point is on this thing, but let's go. Let's narrow this down then. Okay. So what I'm doing right now is I took the spectrum and I'm narrowing it down to just this. This is kind of hard to say. Let's just call that the 0 point. Okay. Good. Let's do calibrate. All right. So this actually looks pretty decent now. All right. Okay, that's a 0 point, and I'm going to do elements type M. Okay, so we got type M, and now I can calibrate this so that it goes. Where are these dips? Use 1 point alignment. It's it's hard to see. Okay, so we got these dips here. Come on. Uh, 0. I don't know. Where is it? Where is it? Where is it? There's my mouse. No, where'd it go? There we go. Okay, so I'm trying to find out where my mouse is. Okay, there we go. There we go. There we go. I'm trying to. These lines fit in dips. Question is, where are the dips? Are they over here? Or are they over here? That looks close. I don't think it's exact, but that's close. Hang on, let's see. Uh, that's pretty good right there. So, all right, let's zoom in on here and take a look. Um, where we have these dips, we got dip right there. That's close to that. That's close to that. I think I'm just not exactly on. Um, those look pretty close. This one's kind of off. That one's slightly off. I think my precision's not quite there. 5. Yeah, I think my precision's not quite there. It's close, but not quite. Um, but geez. And actually, these should be. No, I'm wrong. These should be up here. I think this is better matching up here. So now, where are these dips? Okay, so that dip there, that dip there, dip there, the dip here. That's close. Oops. Let's try this again. And this is apparently this is exactly what's done for the calibration once you have it. And this star just doesn't have a hydrogen beta line. If it had a hydrogen beta line, I could calibrate pretty quickly, but it doesn't. So that's why I use use Vega as a type A star to do your calibration. So you calibrate your filter, you calibrate your camera, you calibrate your telescope. Everything is calibrated on the image. You just find your star, and then you take your spectrum, and then you calibrate it, and then you're good. Then you can figure out other stuff. Okay, so what are we seeing? We're seeing the light coming from Betelgeuse separated out into a spectrum. I just need to play with it more so I can understand just what's going on. Um, I mean, it's really neat. It's really neat being able to see this kind of data. I've I don't know what other way to put it. It's just really cool. Maybe we try to do a 4-second exposure just out of curiosity, just to see what it would look like. If you get more data, if you get better data, worse data. Yeah, I'm not sure. Just not sure. It's such a bright star. Yeah. I just don't know. And it's going way off to the side too. So I just think it's just really bright. I don't think this is quite right. Uh, oh well. It's 10:45. I guess we can do one more object if anyone's got anything special they want to see. I'm gonna go through here. I don't really want to go back to the Orion Nebula. We've already seen it before. We did quite a bit earlier. Um, something to the south, something up high, something neat. Maybe not something directly overhead. Here is California Nebula. California Nebula is really hard to pick out, especially here with the light polluted skies. Um, and also, it's more towards the north as well, so it's even worse. That's good. Witches, maybe the witches brew. This will be a hard one. This will be a hard one. I don't know if I'll be able to grab it. I think this is the witch's broom. IC 218. Okay. Deep sky. I see 2118. No. 2118. Sure. Yeah, this will probably be kind of hard because Rigel is right here. and I don't have it because I should have just aligned it again on. I should have realigned on Betelgeuse once I had in the center view. I could have done it. I just forgot. So this is going to be hunting it down again. In fact, it's probably easier to just put it on Rigel. Let's see. Oh, no wonder. I did 2188. All right. Let's try this again. Back. Ugh. I need to do stars again. Name stars. Betelgeuse. I just forgot. So that's what happens, especially when it's cold. Not thinking straight. I think it's almost 11 o'clock. We're gonna call it at 11. It's already pretty chilly, and temperature's dropping even more. I think we're at I don't even know what temperature is right now. It's just cold. Let's see what this says. Let's see what the old phone says. The phone says it is 35 degrees. Yeah, feels like it. But I'm dressed pretty warmly. I'm not too worried. It's just cold. All right, so we're on Rigel. No, Betelgeuse. Get on the ground again. All right. Once more. Let's see. We're going to switch over to the camera so I can actually see what's going on. Switch to that one. I really just need to see what's happening. I can't do it otherwise. Is this Rigel? Yeah, could be Rigel. Could be Rigel. I won't know until I'm on the ground. Betelgeuse. Okay, it's Betelgeuse. Okay, there is something to be said about uh, keeping your telescopes higher on the tripod. So you're not lying down on the ground to try to look through the finder. Okay, center it. Oh, it. Okay. That direction. There we go. All right. That's not horrible. Over, over, over. All right. Let's just, menu sync to target. Betelgeuse. Sure. Sync successful. All right. Once more. So we're gonna go to deep sky object. IC 222118. I have to say it's really, really uncomfortable. So this is right by Rigel. Rigel may be in the field of view, maybe not. Nope, That's fine. Okay. So what are we gonna do? I'm gonna start guiding. We're gonna do begin guiding. Let's see if it'll do it right or not. Yep. Okay. Cool. So it's guiding. It's fine. Let's do a much longer exposure. Change to RAW 8 to RAW 16. Cool. Not doing that. Okay. I want to do a 30-second exposure. Let's see what happens. Oh yeah, and turn on the cooler. So 5.5 degrees Celsius on the chip. We're going to turn on the cooler, try to get down as quickly as or cool as possible. Not too bad. All right. And see what we can see. Jeez, it's cold. And my phone is so cold it's almost out of power. Yep. It wasn't okay. It wasn't supposed to be out of power till about 2 in the morning, and it's almost out of power now. 30 seconds. What do we got? Not much. Not much. Let's do auto gain. The next image. See what happens. Auto gain, and just for kicks and grins, let's look at the histogram. See what we got. Okay, we got stars. That's it. I don't see anything else. So there's probably some data in there. Probably not a whole lot. I need a longer exposure, but let's see what happens with the gain now. Not much difference, really. I think we need longer exposure. All right, let's do 2-minute exposure, see what happens. We should be in the right area. But again, this is dark nebula. It's the darker the sky, the better. The longer exposure, the better. And I just don't know if we'll be able to get a good exposure on a dark nebula, in a dim nebula, in light polluted skies with a light pollution filter. Just, I don't know. We'll see. Whew. Well, Miguel, worst case, you can always watch this again. So it's not like this is going away. It is quite cold. So I can finish off some tea. Except that the thermos itself is very cold on the inside. Okay, another minute. That's nice. Okay, 50 seconds. Temperatures dropped down quite a bit on the chip. So the we keep the chip as we want the camera to be as cold as possible to reduce the amount of noise. And we can have there are dedicated astronomical cameras that use what's called a thermoelectric cooler or thermoelectric couple on the back of the chip, and it drops temperature way down, usually about 40 degrees Celsius from ambient. So it's a neat trick. It is a semiconductor, and there's a hot side and a cold side. And when you run power through it in one direction, one side is hot, one side is cold. If you flip the polarity, the hot side becomes cold, the cold side becomes hot. And you see these in these little refrigerators that you could buy for your car or truck or SUV. And they plug in, it's a 12-volt system, it just plugs right in. And there's a little fan, it's a heat sink and a fan on one side, and then usually a small heat sink and a fan on the other side. So the cold side has a heat sink and fan to cool down, like your little refrigerated area, and then the heat sink and fan on the outside of the refrigerated and insulated area gets hot, and think of it like a heat pump, basically. It's sucking heat from the inside and keeping the inside cool. So you see these on those little refrigerators because they don't require a compressor. You see them on wine chillers, like a little small refrigerators made for wine, because temperature doesn't have to go down that low. It can stay like in the 50s or so for reds, and they do use a lot of power. but they don't have compressors. They are almost silent except for the fans. So it's it's really nice. Well, these have the same thing, where um, it's a thermoelectric couple on the back of the chip, and the hot side takes the heat away from the chip, so the chip can go down 40 degrees cooler than 40 degrees Celsius cooler than ambient. All right, see what we got here. I don't really see anything. That's the problem. Um, it's so dim. I don't think we're going to see anything. So, unfortunately, I think that's going to be the end of the road for us. It's 2 minutes till 11. It is quite cold. I'm I'm ready to go in. Unfortunately, I actually have to pack up uh, most of this stuff, pretty much all this stuff, except I'm going to leave the telescopes out. I can cover them up, and they'll be fine until tomorrow. It doesn't start raining, I think, until Tuesday. Yeah, or Monday night or Tuesday is when it's supposed to start raining again here. Um, a week ago, we had snow for the first time in several years, so that was nice. Uh, and yesterday it was cloudy, so that's why we didn't do the star party last night, but we did it today. Let's see, raw 16. Let's see what happens when I do it this way. So I switched to the wide angle camera now. I just want to take one last view of Orion. See what we're looking at with the 15-second exposure. Yeah. So there we go. So we were actually looking in this area right here for that dark nebula, and it's just not going to be visible in our light polluted skies, which is really unfortunate. But I mean, what can you do? Uh, can't really force a blackout, which yeah, that'd be nice. But nonetheless, what we have here is Orion on his side. Here's the Orion Nebula coming out really, really nicely. Just out of curiosity, I want to see what the histogram is going to do if I mess with it. Histogram looks nice. Yeah, all right. So we got light pollution. This is actually light pollution from down to the south, from the city of Burleson. And here's Orion up here. So we can see a whole lot of noise, but at least we are seeing something. With this, we can see what area of the sky we're looking at. Um, so the region we're just trying to image is right about here, uh, right in the center of the view. So it's very close to Orion. It's just too much light pollution to really do anything good with. So it is now 11 p.m. Central Standard Time. It is 35 degrees. Um, I'm sitting here without gloves and with a thermos of still warm tea. So I'm going to go ahead and pack up and drag as much stuff as I can, as quickly as I can, back into the house and take a nice warm shower and jump into bed because I have work in the morning. And I'm guessing most of you do as well. Many of you do. So thank you for joining us. I really appreciate this. This is a lot of fun. I do enjoy doing this, even when it's this cold. Um, it's always fun trying out new stuff. The spectroscopy is something totally new. I have not done it before. I want to continue to do it. I will be refining it, making it work right, getting my calibration all done. And it's something that's really interesting. And what I want to do is be able to use it during the course of a night where, oh, we're looking at this star. Well, let's find out a little bit about it. I would like to look at Uranus and Neptune. I want to be able to pull out what elements are in the atmospheres. I want to be able to show how we actually classify stars. So once we have the calibration, um, it's a matter of going through and getting and seeing the different absorption lines and saying, oh, well, this is this type of a star, or this is this type of star. So is it A? Is it M? Is it G? K? What type of a star is it? And show this is how we actually catalog them. So we've actually had satellites that do this. They will take the spectra of stars and just analyze them and catalog them. So we've been doing this now since the 1800s. So this is, Ms. Cannon Jump, I believe it was, and she and her team of women astronomers back in the 1800s cataloged, I believe it was tens of thousands of stars. And is it Mary Cannon Jump? I don't remember. Is it Mary or Emily? I don't recall, and now I'm going to feel bad about it. But her system of cataloging the stars is, let's see, Cannon Jump. Cannon Jump stars. Annie Jump Cannon. Okay, well, that was close. Annie Jump Cannon and 1800s. Yep. So late 1800s to 1941. So she did the cataloging of stars. Yeah, end of the 1800s is when she became part of the Harvard computers. So Annie Cannon. No, Annie Jump Cannon. That's what it is. Annie Jump Cannon. You need to remember that. Annie Jump Cannon. She's very, very important. So her work is what created the catalog for stars, and this is exactly what she did: is doing spectroscopy using a spectroscopy grading on these images and taking that information and cataloging it. So, yeah, interesting stuff. So, again, thank you very much for joining us, and please like and subscribe. Subscribing is how you easily find out when post up new videos and new live streams going on or have them scheduled. And likes, uh, I guess that helps with the algorithm for YouTube. So it helps us get up higher. I, again, would like to do a lot more of these. And if anyone wants to join me on these, we can do dual Zoom sessions. Last time we actually did an in-person one down in Grandview, where we had separation between myself and Zach, so that he could have his stuff going and I could have my stuff going, and it's all doable. This is what we have to do now during a pandemic. It's just getting worse and worse, so we don't really have any other way of really doing an in-person star party. It's just way too dangerous, and the numbers keep increasing and increasing. Even though we have the vaccine out now, um, there's not enough of it yet to make a dent. So yeah, we're gonna keep doing this until we don't have to keep doing this, and even then, I would like to continue to do this. So yeah. Anyway, it's it's well after midnight, and I'm ready to go in. So again, thank you, everyone. I really appreciate you spending some time with me this evening. And oh, let's see. I got a quick question. Let's see. When will I be doing this again? Um, I do these depending on time, my time, and the weather. Um, that's what it depends on. So if I do not have the time to do it, I'm not going to be able to do it. And if the weather does not cooperate, it needs to be really a cloudless, still night. If we have wind, you just can't do it. It shakes the telescope too much, really can't see much. So we need, like tonight, it's cold, but it's still, there's just no wind whatsoever. It's really, really pleasant, even though it is cold. If if it's a little bit cloudy, sometimes you can do it, sometimes it'll clear up. But if it starts getting overcast, especially if it's high thin clouds, there's not much of a point to doing it because we won't be able to see much. Even though you could see stars, the details are all gone from any nebula. Um, and for time, I do work full time, and sometimes I'm not able to. I'm just able to find time to do it. So I try to do it whenever I can. I was supposed to do one last night. We had to reschedule it till today because it didn't clear up until after 11 o'clock. And we've had that before. In the summer, there were actually, I think, two star parties I had to cancel because of, well, hurricane. There were two hurricanes which came through, one right after the other. Um, I try to do them at the first quarter or the third quarter or a new moon, not during the full moon. The full moon washes everything out. So anything close to the full moon, I just don't even bother with. We can look at the moon, and really that's it. There's nothing else to look at because the sky is just too awash in light. Um, and then I try to schedule it usually 3 to 7 days ahead of a window. So sometimes it's a little bit less. It's rarely, very rarely more. I don't think I've ever done it more than 7 days ahead of time, just because it's so weather dependent. Uh, and yeah, and if you have any requests, go ahead and put them in the chat or put them uh, um, in the comments, and then we can work from those. If you have any questions, those go in there. And if you would like to join the Fort Worth Astronomical Society, you can go to facebook.com/Fort Worth Astro, and we have instructions there on how to join. That's probably the easiest way to do it. We do actually have a meeting on Tuesday. So Tuesday, what is it? To the 19th. Um, yes, Tuesday the 19th at 7 p.m. and we will be streaming it live on this channel. So you can watch it there. And we do have a presentation. We typically have a presentation from one of our club members about some topic related to astronomy. So there's always something to see, not just talking about the club. We do actually have some content there. So again, we'll finish up. Thank you everyone for joining us, and that will do it for me. Have a good night.